Okay, this is the moderator. Channel.
Oh, there we go. Hello, hello. All right, I hope everyone is enjoying all these wonderful talks and panels. The next panel we have up is called Demystifying Market Making, and our moderator is going to be Lilla from CoinDesk. Everyone give them a round of applause on the way in. Come on, let's support everybody up on stage. There we go.
Yeah.
Hello? Okay, hi guys. I have David here who leads BD at Wintermute, and then I have Amos who is founder of MetaWeb VC and Adtech. If you guys would like to introduce yourselves and tell me a little bit about what you do, that would be great. David, we can start with you.
Awesome. Thank you so much for having me. How's everyone doing? How's everyone doing? Let's make some noise. Let's give it up for the choral stage. If you guys hanging in this late in the afternoon for a panel while most people are outside drinking or doing something else, respect. My name's David Mickley. I do BD at Wintermute. I've been working in crypto for 4 years, over half that time at Wintermute. Based in Boston. Before working in crypto, I was in traditional finance. I was a client advisor at Bridgewater Associates, a macro hedge fund in Connecticut, and excited to be here on my first ETH Denver panel ever. So thank you guys for making this happen.
Hello everyone. My name is Amos. I'm the founder of MetaWeb VC. So MetaWeb is an early stage VC focusing crypto, and we're backed by Sequoia, Dragonfly, and Senzi of the world. At the same time, we also have a sister company called Adtech. Adtech is both a product studio, but also a trading firm. So we do lots of like prop trading, but at the same time, we're also a market maker for project in the crypto space. I've been in crypto pretty much since 2013. This is my third ETH Denver. Really excited to be here today.
It's also my first ETH Denver. It's pretty incredible so far. A lot of people here. David, I'm wondering if you can speak to us a little bit about Wintermute being one of like the largest market makers in the industry. If there's a particular focus, could you speak to that?
Yeah, absolutely. Sorry. A lot of noise here, but we'll get through it. So first, just want to get a sense of the audience. How many people here are familiar with the concept of market making? All right, good, awesome.
Great.
How many people here are traders themselves? How many people here are builders, developers? For how many people is this your first crypto conference? Awesome, very cool, very cool. Also in the background is my brother and sister-in-law who came from not so far, but some distance to be here. So round of applause, thank you for showing up. Yeah, round of applause. Family, it's not all about crypto. Family's important too. So yeah, Wintermute, we're one of the world's largest crypto market makers. We've been around for 7 years. Basically what we do is really simple, and we just do it at scale. We are providing liquidity across dozens of venues, centralized exchanges, decentralized exchanges, in a market-neutral way. So when you look at an order book, an exchange, Coinbase, Binance, and you look at all those orders, a large percentage of those orders are ours. We're providing liquidity, we're putting those orders up on both sides of the book, and we're basically allowing for there to be a market to buy and sell against, for individual traders, for long-term investors, and we do a few things with external parties. The first is OTC trading. So if you're an investor, a fund, institutional broker or aggregator, and you want to move large amounts of crypto, it's more efficient to go directly to a market maker through an OTC desk to move those blocks. Let's say it's $100,000 or $100 million. You'll get better pricing by going directly to a liquidity provider, and we offer that through our OTC desk. The second thing we do is we help projects with liquidity. If you're a project and you're launching a token, to get that initial liquidity, to make sure those order books are filled and that the project has that liquidity, which is one ingredient, but an essential ingredient for its growth, we're there to provide it. So we can talk more about what that means, and would love to also hear from people that are interested in working with us, either on the OTC desk or the liquidity providing side. You can find me on Twitter, at David Mickley. Just hit me up on DMs if any of those things interest you, and obviously we'll get into the details as we go through the talk.
Amos, can you speak a little bit about your relationship as a market maker?
Yeah, for sure. So a lot of people are more familiar with MetaWeb on the VC side, but at the same time, like our trading firm has also been trading the space for quite a while. I think like in the past couple of months, we're actually usually ranked as some of the top traders on Binance in terms of like P&L. And more related to the market making side, so obviously shout out to the Wintermill, they're being some of the largest market makers in the world. So we have a slightly different approach because we both have the VC side, the venture studio side of things, and also the trading side. So we tend to grow together with the projects, especially for project that we have invested or incubated. In the sense, so obviously in the market making component, we will obviously do lots of data neutral strategy, but sometimes we also like to trade some of the betas to really help the project to grow in terms of the market cap. So we do have historical record of growing a couple of projects, originally from ranking 100 or even 200. I guess ranking on CoinMarketCap, but eventually bring them up to top 50, right? So that's kind of I guess our approach in terms of market making. So if you're interested or if you building a project, obviously just contact me either on Twitter or just go to our website and leave a message there. Yeah.
I think it'd be interesting to hear more about that. Why is liquidity so important for particularly early stage crypto projects and as they progress? If you can speak to that from the sort of VC perspective and also a market making perspective.
Sure. I mean, first of all, let's start with token. So yesterday I actually did a workshop essentially saying that token is the most powerful marketing tool in crypto. And
say that again, sorry? What did you say?
Token is the most powerful marketing tool in crypto. Because all the way since 2017, the ICO bull run, and then the DeFi summer, then Solana and all the other layer ones, and right now layer 2 modularity. Almost all the hype, were driven by press, right? So let's face it, this is very speculative market, and people do want to make money, and there's actually nothing wrong about it. For example, in the early stage, when Solana was trading below $1, they don't have that many projects building on it, right? But right now, there's so many projects, building on Solana, and the same could be applied to lots of other ecosystems, right? So that's why I think token is quite important. And the market making element part is just to make sure, you provide an easy way for people to buy and sell the token, and make sure it's a liquid asset. Obviously, this could be challenging for early stage project, simply just because in the beginning maybe there are not that many interest, not that many knowledge about the token. People are a bit unsure what to buy. At the same time, market making does takes capital and efforts to do it, right? But at the same time, I would say especially since the beginning of last bull run, especially started with DeFi. With AMM and then concentrated liquidity, AMM. Right now, obviously, the threshold and the requirements of doing market making is much easier compared to before when you have to use a market maker. So I would say that's definitely a good start. But I would say market making is still quite essential. Having professional market maker to do it. It's just to make sure people can actually trade, get access to your token, which obviously in the long run will help with the token growth, the project growth, help with the product as well. So.
Thank you. And David, from your side of things, why is liquidity so important for crypto projects?
Yeah, it's a great question. People talk about liquidity all the time. They talk about being important, but what does liquidity really mean? I just want to sort of define that. Looking at a non-crypto market, say you go to the supermarket, the shelves are stocked, right? You want to buy Captain Crunch, you can find Captain Crunch. Who here likes Captain Crunch, right? I love Captain Crunch. And if you want to buy one box of Captain Crunch or 5 or 10, the price really isn't going to change, and it shouldn't, because there's ample liquidity. There's ample inventory on the shelves at the store. So for a project that's just launching, when you get listed on an exchange, all the exchange is a venue. It's the grocery store, but it's not the inventory of the actual item on the shelves. who provides that inventory, who provides that liquidity? It's the market makers. And unlike a grocery store, it's a market where anyone can come and buy and sell things because there are market makers posting that inventory, posting that liquidity on both sides. Now, if you are, a crypto that has widespread adoption, if you're Bitcoin or Ethereum, you don't need a market maker because there's enough natural people buying and selling that there's natural liquidity in those order books across those markets, across exchanges. But if you're a new project that's up and coming, you can have everything going for you. You can have the product market fit, you can have the marketing, you can have the team, but if you don't have a professional market maker that's there to fill those books across both sides, across venues, then traders and investors are going to have a bad experience. When they buy, $10 versus $1,000 of the asset, they'll see slippage. That's not a good experience. Investors, if they see spreads of 2 to 5% for low quantities, it leads to a decreased likelihood that they're going to want to buy it, or feeling that they don't have confidence to be able to sell it when they ultimately need to. Obviously, we heard about, FTX having these huge holdings on things that didn't have liquidity. So you can have $100 million in something, but if there's no liquidity, there's no market, and it doesn't matter. So market makers play a role in just providing liquidity. But it's really important to also know what market makers don't do. They don't help move the price up. They don't help push the price down. They literally are there in a market-neutral way, providing liquidity. And so when Wintermute thinks about partnering with projects, we try to identify projects that have all those other things going for them. That they have the marketing, they have the team, they have the product market fit, they have the conviction, and we use our team of developers, engineers that have been working on market making, a very simple idea, but very complex in execution, trading billions of dollars a day. We apply that technology to providing liquidity to your token as part of our role in helping support that project.
Great, thank you. I'm curious about the way market making differs for centralized exchanges versus decentralized exchanges. So I know at Wintermute you provide liquidity for both, right? How does that look? Because I think over the last sort of year or so, we've seen decentralized exchange trading volume sort of not look as good as it did in previous years. I think there was, at one point, we saw, I think Uniswap and a few other decentralized exchanges trading volumes surpass Coinbase, which was pretty cool. I'm wondering how that looks from a market maker's perspective, and if there are stark differences or not.
Yeah, sure. I'll start with that. Definitely. Trading in general is picking up right now. We're entering a bull market, but DeFi's market share has been decreasing a little bit. The peak for DeFi's market share was around May of 2023, where 15% of trading happened on chain, and now it's around half that, around 7.5%. So it's still meaningful, but as far as market share goes, definitely the majority of trading happens on chain. As market makers, both on CeFi and DeFi, we're very active on chain. There's all sorts of different venues that you can trade on. There's AMMs, which introduce certain risk around impermanent loss. There's CLOBs, which sort of eliminate that, but have other sort of issues around optimizing for gas, optimizing for transaction fees. There's just a lot more things you have to consider when trading on chain. But for us, it's really important that when someone's buying or selling a token, we want them to feel like they got a fair price no matter where they traded it. So we want to make the markets efficient across both types of venues, CeFi and DeFi, and our ability to be active on DeFi and active on CeFi allows us to keep the price in line through arbitrage. That's what market makers are essentially doing. They're capturing the bid-ask spread on a given exchange and arbitraging the price difference between exchanges. And for us, we're not just arbitraging between different centralized exchanges, but we're arbitraging between CeFi and DeFi to put the price in line, and so that if you buy something on Uniswap or if you buy something on Coinbase, hopefully you'll still see relatively the same price. But obviously there's challenges, there's more work, there's more integration work you need to think about when doing market making or trading on chain, and that's why we have a big team of DeFi developers focused on that, because we're very committed to furthering the decentralized world in general.
Amos, I'm wondering if you could speak to that too?
Yeah, I think trading on a DEX is actually very different from trading on the central exchanges, especially if you're trading on AMM, because especially I'm talking about Uniswap V2 style AMM. It's both like the smartest and the most stupidest design in the world, right? So it does introduce slippage, and obviously right now I would say the general user experience of trading on chain is still not necessarily comparable to the experience of trading off chain on a central exchange, right? Sometimes there are latency. And by the way, right now there are lots of order book, decentralized order book exchanges, but it's not exactly fully on chain yet. And I guess one of the big benefit of trading on a centralized exchange, especially from the project perspective, because at the same time I'm a VC, right? Is that like David said, central exchanges, they're just like venue, they're like grocery store, and they can actually bring you lots of users. Versus like on DEXs, generally speaking, it's more like the project actually bringing users to the DEX versus SEX is actually bringing user to the project, right? So there are definitely like much, I would say, like stronger benefits for a project to get listed on central exchanges compared to a DEX. But in terms of all the actual trading mechanism, I say there wouldn't be that much of a difference. But just in general, like if you try to trade on AMM, it's not like a very efficient way of doing it in most cases. Obviously, you still have to pay gas fee and deal with all the MEV stuff, which sometimes tend to like really complicate things, right? But at least like in this bull run, I'm actually quite bullish in terms of having more decentralized exchanges, especially order book exchanges like showing up. We actually invest in 2 projects are working on this. One is called Orderly Network, which is actually a pretty large project. I think they're doing like billions of dollars of volume right now. It's actually built by the Wu team. We also invest in another project called Warp, which is a fully on-chain order book built by Joseph Pong, who actually wrote the Lightning Network white paper together with Vitalik back then. So super excited about that.
I'm wondering how early stage projects compete in terms of liquidity. So, David, I think you explained this at the beginning. Like, if an asset has like high trading volumes, it's obviously advantageous. So, how do the earlier stage projects compete with that?
Yeah, great question. So, for early stage projects, that is kind of the inherent problem: is getting liquidity, getting people to actually have the market that they can trade against, and that presents a few problems, right? When you're trying to get listed on an exchange, you have to think about their incentives. All the exchange cares about is trading volume because that leads to trading fees. So how do they know people are going to trade this new token that is being listed? Well, when a market maker is working with a project, that again goes back to the metaphor, that's filling out the inventory. That's putting the cereal on the shelves so that people can buy and sell it. And that allows the exchanges to make money through trading fees. And that allows the market to be created so that there's people that can actually buy and sell the thing. So that's why, again, it goes back to why are market makers important? It's for providing that liquidity before something actually has an organic market of people that are willing to post orders across both sides of the book. Again, you sort of look at the orders of magnitude of trading volume. BTC yesterday doing around 70 billion, ETH doing around 30 billion. There's only a handful of projects that trade north of $1 billion. And then it drops into a few in the hundreds of millions, and then way less in the tens of millions, and then way more in the tens of millions, and then way more, way below that. So if you want to get trading volume, you need liquidity. Both those things go together. Liquidity brings volume, volume brings liquidity, but to bootstrap it from an initial stage, especially when you're launching a new project, that's when the market maker can really play a role.
And does the market maker take on any risk by providing liquidity for like super small, lower cap projects?
Yeah, do you want to answer that first? Yeah.
Of course, I'll say there's definitely more risk in a bear market because to provide really good liquidity, the market maker need to both buy and sell the tokens, right? So if the token just keep going down, obviously to still try to remain the liquidity, the market maker just gonna keep buying the token. So there's definitely like inherent risk. And in terms of like hedging the risks, because a lot of smaller projects actually don't have futures or perps, it's also really difficult to actually hedge it. So I would say that's definitely like one of the challenges of doing market making for smaller cap projects. But I guess to answer your early question, I would say just provide like slightly different perspective. First, I agree with what David said. But the other part is that once you figure out like all the market making stuff, make sure people can trade it somewhat easily, have a somewhat smooth experience of trading our token. It's also very important for a project to actually compete for attention, which doesn't necessarily means like market making, but it's more like a marketing in that sense. Like the project is like market making, just like one of the instruments. The other part is more about getting more people to know what you're doing, getting them excited. Obviously, the product itself need to have like good value proposition, actually have good utility and capture value. All those are important for a project to actually compete. For the traders, for the retail users, for the funds, like attention to actually buy into the tokens, and the market making is just facilitating the transaction in between. So.
Yeah, and just to build off that, really good point about the hedging risks. It's hard to hedge something when it's not an actively traded token, but there's also the opportunity cost of trading a. Is that better now? Can you not hear? Now you can hear? Okay, great, thanks. Oh, you were scratching? All right, scratch, you edged it, it's good? All right, it's good, great, awesome. So, where was I? So yeah, basically there's also the opportunity cost, right? So the way we structure our deals is we get a loan from the project in the token that we'll be market making. But we have to put up the other side of whatever that token is trading against, whether that's BTC, ETH, or stables. There's a capital cost there to put up that other side of the trade. There's an opportunity cost of what we could be doing with that capital. And right now, the cost of capital, the opportunity costs are very high because it's high cost to borrow. There's a lot of trading opportunities. So the worst thing for a market maker, well, not the worst, but one of the bad things, is if we are posting liquidity, but no one's trading against it. That's just kind of destroys the business model. So what you were asking before is the risk of working with an early stage project. We want to make sure that if that project is launched and if there is good liquidity, that there is a market out there that wants to buy and sell it. Because otherwise, we're just posting our inventory and it's not being used, and that's an opportunity cost. And that's why we assess projects as part of our diligence process to basically see, like, are we working with projects that there is an active user base of people that want to trade it, buy and sell it, and so forth.
How do you gauge that demand?
It's really tricky. It's really tricky. I mean, it's almost like a VC type of diligence. We're looking at community, we're looking at product. If it's already traded on a DEX, then we can get that sort of information before it lists on a centralized exchange and see how much volume is already there. We look at the backing. It is somewhat of an art, as investing is. But I would say it's a real decision of investing our resources and capital in market making, and you don't always know until it launches.
And then just one more thing on the opportunity cost. So right now, like the funding rate on Binance for perps, even for BTC, the implied APY is actually more than 100%. So that's like real, opportunity cost, to market makers in that sense. So
I want to ask you guys one last question. So, at what point do you think we're going to see like a consistent sort of in crypto? There's a lot of spikes of trading volume, like high active periods. At what point will the market sort of become consistent from a market making perspective, from a trading volume perspective, liquidity? When are we going to see that?
I actually don't care if it's like consistent. I guess more like constantly growing the market share and get more and more volume, right? But like just as in traditional finance, there will always be like spikes in volume for whatever reasons, and that's actually great in terms of the volatility to the traders. But overall, I'm just hoping this market, especially with the recent ETF approval, just bring like more people into the space, more money, which obviously is great.
Yeah, great points. And just to add to that, obviously we're still early in widespread crypto adoption. So much of crypto price action is based on sentiment, based on news, and that can shift very quickly. So the more that we can have broader adoption, broader use cases that create stability to pricing, that creates stability to the markets, a wider sort of base of users, buyers, and sellers, then we'll see volatility come down. So it's really this way with any emerging asset class. Crypto is one example of it. And I think as we see more adoption, then we'll see more stability. And obviously, we're seeing that over the past 10 years. We just have a long more way to go.
Thanks so much, guys. That's all we have time for. I appreciate it.
Awesome. Thank you.
Thank you,
So I'll
guys.
say one more time. If you want to follow up, Twitter, @DavidMickley, hit me up. And thank you all for having me. Great being on the panel with you.
Thanks both.
All right, all right. I hope you guys enjoyed that awesome panel today. We've got another wonderful speaker coming up. We have SY from Story Protocol, and he's going to be talking about intellectual property in the age of AI. Everyone give SY a big round of applause.
Thank you. This is SY. I'm the CEO and founder of Story Protocol. And we're building the programmable intellectual property infrastructure in the age of AI. And today I want to, because we've already done the demos in the earlier part of Ethereum Denver sessions, I want to really focus and deep dive on the state of AI, the state of IP in this age of AI, and kind of talk about what we can offer as a solution. So from the perspective of intellectual property, the biggest thing about AI is the fact that it represents insane amount of content getting pumped out at a very short scale. So look at this graph. So the amount of images that actually AI produced in 1.5 years is equivalent of amount of images that's actually been produced by photography for 150 years. So it's basically it represents an insane amount of superabundance of content at an incredible speed that's unprecedented. And really trying to abstract and see we want to think about having the right mental model of to think about the superabundance. I think Ben Thompson of Stratechery actually had a really good way to think about how to think of AI, what AI is doing to IP. And he basically says every single technology disruption unbundles a part of creative process. Writing unbundled consumption, writing and literacy unbundled consumption, printing unbundled duplication, internet has unbundled distribution. Anyone with a social media profile can instantly distribute to everyone in their world with zero marginal cost. In the same way, actually, generative AI is unbundling substantiation. You can have an idea, a bullet point of ideas about your next fiction, next movie concept, and it will actually turn it into a fully fledged fiction, prose, movie, anything. And actually what's probably the most incredible thing that came out recently is what you've seen from Sora. And anyone as a dog parent would know how hard it is to get your dog to look at your camera. And actually you get this kind of incredible result with the sentence. So the whole process of substantiation is gone, which means there's going to be insane pace of content creation because you no longer have to have this lengthy process of substantiating your content to have a fully fledged product. And this is going to get worse and worse, or even, the pace is going to get greater and greater, right? Because the amount of compute that's going into AI is exponentially increasing. Actually, that Moore's law almost like went from 20 months to 6 months after 2010. The amount of data getting into actually training this model is exponentially increasing too, which means the infra is accelerating, and actually the pace of this AI pumping out content at a faster speed and actually having higher resolution substantiation will never decelerate. It will only accelerate. So we will see exponentially growing abundance of content going forward. And in that environment, I would like to argue actually the gating problem of AI is not the speed or performance or getting to a higher resolution substantiation, but it's actually attribution, provenance, and compensation. It's the intellectual property that is the problem, right? And don't we have actually an IP infrastructure already, you may ask? It's the copyright law, right? But the copyright law is all based on this idea of mechanical reproduction, right? The copyright law only knows how to actually punish or protect or incentivize if someone's actually copying your content, right? But it doesn't. But AI is not a copying machine. It's not a printer. It's unprinter. It's a creative generative machine that takes all this data and gobbles up the data, takes the essence, and creates something totally new, creative, generative. And copyright law, which thinks in terms of mechanical reproduction, doesn't know how to wrap their head around, right? This generative creative machine. They've only know how to deal with copying machine, right? And what we are seeing is that the copyright law only knows how to cover and deal with the previous generation of content. But actually now, the internet is getting carpet bombed by generative AI. Now you'll see most of the internet's content being generated by Gen AI models. In that world, how do you assign provenance attribution to the content that's gone in, the content that's gone out of the AI models? So we need a new IP infrastructure that's going to cover this Gen AI age, right? And actually, this is already playing out. You see the New York Times OpenAI lawsuit, right? You've seen the Getty Images, Stable Diffusion lawsuit. And New York Times, if you ask about New York Times article, it gives an incredible synthetic output, right? And what New York Times is actually arguing is that this is actually worse than what the Web2 big tech, the previous generation practices that big tech used to do, because at least back in the days, big tech was decent enough to drive some traffic to your websites, right? It gives your website at the top of the search result, and you can actually go to that website, and we will make some money from that traffic. Now, there's no need to actually go to these websites, right? You get the synthetic output, really incredible synthetic output on the AI interface. So what it means is the AI interface will get all the upside of this incredible things that coming out of this incredible technology. And there's going to be no traffic, nothing getting back to the websites or entrepreneurs or creators. And this is actually a classic tragedy of commons situation. Think of internet as commons. Actually, all of us, especially the creators, are creating incredible outputs into this commons. And actually, these AI models are using these works to create an amazing AI model. But they're taking all the upside. The creators are not getting benefited from this AI revolution. And there are three actually visions of how to actually, how actually now the current big tech is trying to solve this or is dealing with this. The first is the kind of the Adobe model, which is a walled garden model, which is we're only going to train on the images that we own, right? But this is incredibly bad for actually creativity of the internet, because this is an incredible technology, and only the people with incredible number of images can actually benefit from the upside of this revolution. So it's not actually incentivizing entrepreneurship and creativity. The second one is the OpenAI model. Let's not put fences around these IPs where we'll take away all the data, but we're going to charge for it. They make all the money, but the creators are not making money at all, right? The third is the open source model. We're going to get all the data, works. We're not going to charge for it, but still, the creators are not benefiting, right? So if this internet goes into this direction constantly, what we actually think is it's going to actually get to the tragedy of commons. The internet is going to become a barren land. You may see the flourishing of Gen AI content, but the humans don't have the incentive mechanism continue to pump out the content that is going into these training models, which is actually a very bad outcome for all of us, right? So what we need is actually a new IP infrastructure to address this massive challenge that's going to put us to the brink of tragedy of commons. And I just want to give a quick historical context. If you think about basically IP infrastructure, every breakthrough in technology requires a new way to incentivize creators. Basically, that's what IP infrastructure, IP layer means. And the printing technology was the very first outbreak by unbundling duplication. And the writer and author didn't have a way to actually have a claim of ownership over these copied works. And only when copyright law became an IP layer that's administrating this kind of new paradigm of technology, actually you saw things like Shakespeare and Charles Dickens come out. In the same way, we are at a very big revolution, like the printing technology, generative AI, unbundled substantiation. There's so much new content pumping out, but there's no way to actually get provenance attribution, right? And now, with that, actually, we're getting to the tragedy of commons situation. So I think you may ask, what is a better way forward in the situation, right? Is there a more sustainable model to actually fix the situation? And I think we argue that there's two main principles around actually having a more sustainable future of the internet. The first is that creators actually have to own their content, and creators should be able to set licensing terms around their content. How other people can use their content. So they should be able to assert their rights and licensing usage terms over to the internet. And these terms have to be actually machine readable and machine writable, including AI models. So the AI models can actually go and parse through all these data and all these works and get very, very actionable next steps in terms of what they can do. If you want to actually make a commercial model, you should parse through all this data and actually exclude the ones that actually ban commercial usage. It's only for non-commercial usage, right? Only when these principles are actually enshrined and upheld, we think we're going to have a more sustainable future of the internet. So we think there are multiple paths to this, go to this future, but we have a workable solution in the name of programmable IP layer. And we want to explain what that means to all of you. So the programmable IP layer is basically where the IP layer, where IPs are captured on chain. So the creators own their IPs, but creators can also set self-enforcing autonomous rules of engagement around their IPs. And these rules are actually machine readable, writable, including AI models and AI agents. And to actually give you a very quick comparison, because most of you are from crypto, the best analogy is, I think, programmable money. Programmable money took away all the middlemen in basically financial transaction, financial intermediaries. And the beauty of programmable money is that now money is code. There's a built-in API for money, and money can flow from Uniswap to Ethereum, to Compound, and anyone can build so many different type of applications on top of this programmable money, right? In the same way, what we're doing with programmable IP is now actually this creative assets can interact with applications and software in a very frictionless, permissionless manner, and many different people, creators and software, can build interesting primitives on top of programmable IP. And you may ask, has this already been enabled by NFTs, right? But NFTs really is what it is at the moment, is a pointer to a media file, right? It gives you ownership and scarcity to this media file, but NFTs at the moment are very static. It's kind of trapped. What I mean by that is a program like, let's say you have an AI chat, character AI style application. Let's say you want to take all the Bored Apes, you want to take all the Pudgy Penguins to create new AI chatbots. How do you do that? You have to actually talk to there's tens of thousands of owners, talk to a bunch of lawyers, and have tens of thousands of legal negotiations going on in parallel, right? The NFT doesn't have the programmable layer and composable layer to be machine readable, writable, let alone any AI models, right? So what we actually do now is we have this programmable IP that we've created as a primitive. Now, with these programmable IP have on-chain rights enshrined in their IPs. And now any software, including AI models, can actually read and write on top of this NFT, this IP asset, frictionlessly. And when we talk about programmable IP, it's basically what we call IP asset. And there are two elements to it. First is what we call the noun. Noun is basically the essential metadata around the IP. And not only just pointer to the media file, it has the relevant on-chain licensing, on-chain royalty information around the IP. And how we enable this is actually through the token-bound account model. ERC6551. And once you register the IP on our protocol, you get a story protocol bound account. And actually, the smart contract wallet that you get through the token bound account model will store all the on-chain licensing and on-chain royalty information into this wallet. And how we actually enable all these functionalities is through our verbs. These are the functions. These are the enablers of our primitives. And actually, what we do is you have an IP asset getting registered onto our protocol. Now with the module, like licensing module, you can set permissionless licensing terms around how humans and also softwares can interact with your IPs, right? You can set non-commercial and commercial usage. You can set royalty terms. You can say you want upfront licensing, fee. You can also even choose arbitration method. You can even choose whether you want to uphold ledger authority or legal authority, right? And once we have all these primitives, we have a fully end-to-end programmable IP infrastructure. And actually now all the key three principles of what makes a better future, sustainable future is all there. Creators actually own the IP. Creators can set the rules around their IP. And machine can read and write on top of these rules really, really easily and permissionlessly. And don't think we're going to do all these alone. We have a lot of partners building on top of us to actually make this more sustainable future possible, right? The first application is really registering training data or training data sets as IP assets. Now, all these data or data sets will have their on-chain licensing terms, commercial versus non-commercial, how to split the revenue. And actually, we have some interesting hackathon projects joining us to actually innovate on actually the training side of things. Secondly, what we're doing is also the AI models themselves can get registered as IP assets. All the outputs of these models are also IP assets on top of that. And we have a provenance and attribution around what's actually getting sped out of this model. And AI models themselves can be forkable. You want to use someone else's AI model and fine-tune it, there's now on-chain licensing terms around that. Not only that, we have actually partners like Magma, which with 2 million artists. Actually now, they're registering their finished asset and actually saying they have a proof of original work. Or, okay, this artwork was mostly generated by AI. All these things are actually getting attached to the IP as an essential metadata to basically describe whether this is human-generated or AI-generated, right? So now we have a very interesting primitive where everything from training data to the AI model and the outputs of the AI model having essential machine-readable data around what kind of on-chain license terms it will have, whether it's human-generated or AI-generated. And some may ask, I think, okay, how are you going to get all these IPs to actually have these on-chain licensing terms? And I think when people ask me that, I would actually like to point out the case of Napster versus Spotify. And when Napster came out, everyone was downloading music for free, right? For 10 plus years, no one really solved this issue. And really, it's when a very small startup in Sweden called Spotify started working with very few recording labels in a very small country, small market, and really showed a more sustainable future, things get started to be solved and had people saw a better future, right? So what we need to do in, I think, the world of crypto, because crypto gives now scarcity, attribution, and provenance, we should ally all with each other and one another actually to show how actually this IPs with the right on-chain licensing terms can be a better future for creators and IPs overall. Thank you so much.
My port if we want to do that, or if we want to. Did it connect?
Yeah, we're plugged in. I'm just waiting for him to confirm that he sees you.
Cool.
You were the one that asked about making sure it wasn't a mirrored display, right?
Correct.
You want to go make sure.
Yes.
Yeah. I would say don't mirror. Stop mirroring. Yeah.
Good.
And then the decimator is the video interface.
Yep.
So
Perfect.
he's still doing something. So.
Yeah. I'm gonna go ahead and adjust this.
Yeah, for sure. Want it higher or closer?
Lower a little bit.
Lower?
Yeah. That's good. Cool. Perfect.
Get right in there. And
Yeah.
sound.
Test, test.
Yeah.
Let's go.
Great, yeah, so he's got you. So come
All
on
right,
off
cool.
stage. We'll let. So.
Hello, hello. We've got some really awesome talks out here today. We've got Carl coming up, and he's going to be talking about making blockchain data more accessible. Let's everyone give Carl a big round of applause. Bigger, bigger, bigger. There we go.
Hello, hello. We getting a presentation up here, or? Cool. Let's go. Blockchain data. Enter full screen. Here we go. All right. Hello, everybody. My name is Carl DiClementi. I am the head of DevRel at QuickNode. I've been working in the blockchain space for about 7 years now. Previously, I was at BlockFi and a blockchain foundation known as Factum. Today, we're going to be talking about blockchain data and why it's hard to access. We're going to talk through some of the common solutions to access it, as well as how to make a blockchain ETL that doesn't suck. Now, this is all going to get a little bit conceptual, right? Blockchain data slides don't really go well together, so we're going to have our friend help us out. Meet Chad the DGen. Chad invests in dog coins. Chad sends GM messages in hundreds of Discord servers every month just to try to get NFTs, right? Chad has his crypto spread against dozens, if not hundreds of wallets, conducting hundreds of transactions so that he can farm all the tokens that he can get. For most of us that are building products, right, Chad is our target demographic. He generates volume, he pays transaction fees, and he's very active on social media talking about our products. So, you're right, Chad, you don't struggle with blockchain data. Everyone building products for him does. So, what we do is blockchains offer this really awesome, decentralized, global data store, right? No one needs permission to be able to work with it. And with that, Chad's able to send crypto to anyone in the world for really low transaction fees, 24 hours a day, right? He can interact with smart contracts, he can mint NFTs, do NFT swaps, et cetera, et cetera. Cool. So what about all of us that build products for Chad, right? How do we retrieve the data that he needs, right? All of his degen activities. Chad expects a Web2 quality experience with personalized experiences and fast load times. This should be easy enough, right? All the data on the blockchain is public. How hard could it be? Well, just because something's public doesn't necessarily mean that it's easily accessible, right? What is accessible is access to blockchain nodes. And as what many of you may know, right, access to blockchain nodes means that you're using an API, typically referred to as an RPC API. Well, this is you just out of blockchain development 101, building your first application, right? You're attempting to make your RPC calls, and you're finding, hey, this is really easy. I can make an RPC call to get a transaction, and I can see it nice and easy, right? It's free in a lot of situations. You can go sign up for a free account on QuickNode, various other providers that you probably shouldn't sign up on, or you could run your own node. And that's great, right? You can immediately get started, you can access the data right away, and the APIs are standardized, right? No vendor lock-in. What other place in the world can you access that? That's awesome. But when you first start using RPC APIs, then you get humbled pretty quickly. You start to find that the data is encoded, right? Decoding interactions with smart contracts requires access to these ABI files that are hard to find, and they're also not on chain, which makes it extremely difficult. Data, when you want to extract it, you have to extract it block by block. You can't just say something like, hey, for Chad, give me all his transactions that he's had. You have to slowly go through and say, okay, in block 1, let me filter down to all the transactions for him. Block 2, block 3, block 4, which is extremely inefficient, right? And also, the transactions that are happening that are associated with Chad aren't easy to just see, hey, let me see his to and from address of a transaction, and that's the ones that are associated with him. No, it's a lot more complex than that based on the smart contracts he's interacting with. So really, to get all of the information that Chad needs, you could be doing billions of API requests across chains. So in summary, right, Node APIs are good for requesting a single transaction, right? Or are they? Let's take a look right here at the API response for a simple transaction for a USDT transfer. Yeah, I can't read it either. So to decode this, right, we need access to the ABI. And once you can find it, it's actually pretty easy to show something like what Etherscan is showing right here, right? For those of you who over there can't see, it just says, hey, it's a transfer of 40 tether from Chad to random address. So Chad's happy, right? He can see his transaction. Well, what if we want to show him a more advanced experience? Something like, hey, what are all my ERC20 token transfers? Well, that would require millions of API calls to the node, something that Chad is not going to wait for or be willing to pay for. So enter enhanced APIs. Some really good examples that you guys are probably familiar with are things like token APIs, NFT APIs, transfer APIs, etc. This is really nice, right? They handle some major use cases very well. They provide the data decoded, easy to display to Chad, no longer worrying about finding ABIs, etc. They're typically really inexpensive, which is very nice. And you can immediately start using them. You're starting to hear me say that because that's not going to be true for some of the ways to access data that I'll mention later. Unfortunately, not all enhanced APIs will meet your most basic needs. There are exceptions to everything. If you want to have an NFT API, right, that might not support something like CryptoPunks, which doesn't meet NFT standards, right? And if Chad owns a CryptoPunk, you better assume he wants to see that in his wallet. So, the premium providers, of course, they're going to support those things, but they start to become more and more expensive. So where you'll start to run into more challenges is something like, hey, I want to do something unique that's different from every other platform out there, right? I want to present the data in a unique way. I want to be able to pull some unique data off the chain. Well, with enhanced APIs, you're kind of stuck with the standard interface that everyone else is getting, a fixed set of API methods with a fixed set of fields that'll be in the response. And if you want to start enhancing that data, then you have to figure out, all right, well, I'm going to call this enhanced API to be able to get an NFT purchase, and then I'm going to call this other one to be able to get the price of Ether at that time, so that I can say, hey, this is how much it was in NFT, in US dollars, and that just starts to get pretty cumbersome at scale. Another example is if you want to start to do some, custom logic, like, hey, show me the total balances across 50 of Chad's addresses. Right? Chad doesn't necessarily care about like, oh, I want to go to one wallet and then the next one and then the next one and then I want to do all this math in my head, right? He just wants to see his total balance, right? His total net worth. To do that, you're going to be stuck making at least 50 API calls, if not also calls to a price API. So NFT APIs, where they're good for really straightforward standard use cases, if you're trying to do math or any form of aggregation with the data, you start to run into issues. Raise your hand if you've heard of subgraphs. Great, okay. Raise your hand if you've worked with something like the Graph or Zeev. Good, okay, so people are familiar with some of the challenges here, but for those of you who aren't, subgraphs are an extremely powerful tool. It really actually seems like magic when you first start using it. All you have to do is you start to select something like, hey, here are the contracts I'm interested in, make some additional minor configurations, and then come back in a few days, and it'll have indexed all of the transactions, events, etc. Once indexed, you can really query it very powerfully, usually through a query language like GraphQL. Some people find this to be advantageous. Others find it to be a challenge because it's a completely different networking layer at their edge that they have to interact with. But it does allow you to do flexible queries, something like, hey, give me all of the addresses that Chad has ever traded with, right? Which for a wallet could be a really useful thing to provide so that you're not accidentally putting in the wrong address, you just reuse a previous address you've worked with. Also, there's a lot of value in some of the features that the graph provides where there's like pre-made off-the-shelf graphs, subgraphs, right? A really good example is Masari. They make a lot of them available and easy to use. Where people start to run into challenges with subgraphs is kind of the initial indexing time. This is where I was getting into with the fact that enhanced APIs and RPC allow you to immediately start using them. That's usually not the case if you're making your own subgraph. There's a time in which you need to wait for the index to get created. And that's not really that big of a deal in isolation. If you're just launching a new product, it's okay. All right, I'm going to take a few days, I'm going to build up my index, and then I'm going to launch it. But the problem becomes if you run into an error during that indexing. You have to redo that index again, and if you have a bug in your system, Chad's not going to be happy to just have to come back 3 days later for it to be resolved, right? So that's not actually the only delay you'll experience on some graphs. A lot of them have a little bit of a data lag for the data to be processed on chain, then go through the data pipeline. So if you want to give Chad the ability to be up to date on the latest activity on chain, so he's most informed, this might not be the best solution for you. One of the most significant challenges that we found that people run into actually is that subgraphs and the processing are actually a little bit of a black box. So if you want to be able to process something like off-chain data and pull it in, while some platforms do allow you to do this and have this composability, it becomes a really big challenge to be able to debug that. And we found that our customers prefer to be able to pull things into their own data warehouse and process it through their own data pipelines. So overall, subgraphs, extremely powerful tool, but the feedback that we hear is that they prefer to have their own data warehouse. So this data warehouse, right? By pulling the data into a data warehouse and building your own custom index, you've unlocked Jedi Chad. The possibilities are pretty endless when you have the data in your own data warehouse, right? You can do any kind of visualization or personalization for your users. You have access over SQL, or you can write apps above it to interact with it in any language of your choice. And it has tight integration into your existing data pipelines. Let's say you have a Web2 platform and you're doing some form of processing, maybe bot detection as well, things along those lines. You can do that powerfully within your own warehouse. Also, you have composability with additional data sets. That is a huge challenge with subgraphs. Something like even cross-chain data gets very difficult with subgraphs. So this is a way that allows people to do that at scale. And you can enrich that data, right? Like I mentioned, something like being able to have bot detection or run analysis to determine wash trades, right? Start to get to that real data that might get away from this banter that we have on Twitter these days about, oh, hey, this is how many DAUs I have. Well, like, are those actually users, or are they just addresses that are being farmed? So, you know, let's say we want to be able to help Chad report on his taxes with cost basis info. That requires off-chain data of dollars, right? Let's say we want to show Chad the Twitter handle for the owner of an NFT he wants to buy. Well, again, we need to marry in off-chain data. Chad's ROI over time, right? Or chart Chad's ROI over time. These are all really important use cases that any, you know, user wants to be able to have solved. So building all of this, of course, comes with its own challenges. Again, there's an indexing delay. You have to go and you have to scrape the whole blockchain. Again, that could be millions, hundreds of millions to billions of API calls. And an advantage here, though, as opposed to subgraphs, if subgraphs, you usually have to redo your whole index if you have an issue. With this, you might be able to identify, hey, I only need to re-index a subset of the data. Reorg handling. Who here knows what a reorg is? Okay, real quick. Reorg means that historic data on the blockchain changes. Means, what a surprise, blockchain data actually isn't immutable to start. This actually is a bigger problem than people realize. They only find it when they start to build something like this. For example, Ethereum has over 30 reorgs per day, so it's not something that's an edge case. You have to solve for this. Polygon will have reorgs that go back up to 10, 20, 30 blocks that you might have to go and reindex. That becomes a huge challenge for people building these systems. And obviously, building all of this comes at a cost. You have your engineers that need to try to build out an indexing system, scraping the data from the chain, identifying, okay, well, I want to be able to do this as quickly as possible. I only have a rate limit up to X RPS. How am I going to maximize that? Build in my retries for errors, handle my reorgs. It's a lot. And then, obviously, there's the maintenance and the infrastructure to run that. So maybe the key qualifiers, if a custom index might be right for you, is you want to do any kind of advanced differentiated experiences for your customers. You want to be multi-chain, you want to marry in off-chain data, and you want to be able to have data enrichment pipelines, things like wash trade detection or bot detection. But what if there was an easier way? So today, we launched our Streams product, where instead of you having to pull each transaction, each piece of data off the blockchain via an API, we actually feed it directly to you. We take the raw data and we feed it to whatever data store or messaging service you might be using. You can see some examples right here. For the people on the other side, we have examples like webhooks, S3, Kafka, Postgres, Snowflake, etc. What is it that you're using? We want to make it as easy as possible and available to you. And with that, you know, it really solves some of the core challenges associated with extracting data. You know, the reorg handling, that is a huge problem for people. We provide tools to do that for you. We'll restream the data. If you want to just overwrite within your system, you can do that as well. You can set up a trail delay so that it doesn't end up running into the reorg at all, etc. Early customers of this product have seen a significantly faster backfill versus RPC. Especially when you can hook directly into your existing systems and you don't have to worry about some of the latencies associated with APIs. That's where they're seeing the most impact. So while Streams might significantly reduce your data extraction, infra, and engineering overhead, there's still obviously some limitations to it. One is that we only give the raw data. We're not processing the data. And this is actually a purposeful design decision on our part, and that's because we want to get it to you as quickly as possible. We have customers that say, hey, I want to be the one processing it. I have my own pipeline set up. I'm providing differentiated experiences through this. So we want to just get them the standard on-chain data. Also, still, to provide these experiences, you need to build and maintain infrastructure for the in-house transformation. Or do you? Also being announced today is Functions. Functions is akin to AWS Lambda. Raise your hand if you know what AWS Lambda is. Okay, great. So that allows you to just take arbitrary code, run it in the cloud. In the context of streams, this really allows you to do things like filter the data. Let's say you only want to send data downstream for, I don't know, ERC20 token transfers. This can significantly reduce the load on your infrastructure as well. You can also transform the data right at the edge. So decode the blockchain data or structure the data in a way that your destination might want. Let's say instead of sending it into your data warehouse, you want to be feeding the data directly to Twilio to send text messages to your users. You can do that right within our function, configure the request directly how Twilio expects it, and then no longer have to run any infrastructure on your side to make that happen. And obviously, you can also enhance the data with API calls to additional services, right? So let's say you want to make a call to a CoinGecko API to be able to get the price data, or you want to make a call to IPFS to be able to get the NFT, right? You can do that right within these functions. This is all available in your choice of language. Out the box, we support JavaScript, Python, Ruby, Go, PHP, Java, .NET, and even Docker images. So pretty much anything that you want to be running, you'll be able to run at the edge on our infrastructure. And now this means that you've freed up your engineers and infrastructure budget to be able to provide more strategic experiences to your end users. So what are the challenges that we still have left, right? Obviously, you still have to build those functions, right? You have to figure out how to transform and decode that data. As the head of DevRel, that's actually one of the things I'm most excited about is start to provide a library of functions for people to use so that it's one-click deploy and it does it the way that you want, enter in your code, whatever it might be. And I'm really interested to hear from you guys if you're looking to build something using these tools. How do you want to use it? Because something like Lambda is infinitely configurable. Whatever you want to build, right? I'd love to hear it. Also, we don't necessarily know what other challenges people are going to run into yet because we don't have customers using it. It's in private beta. We're ready right now for people to sign up, and start giving it a try. So to summarize this all in one chart, this is my attempt at it. On the left, you'll see something that I call total costs. Some of you might be familiar with the concept called total cost of ownership, TCO. That is your infrastructure cost, your engineering time, as well as the services that you're using. Again, Node APIs, very low cost. Enhanced APIs, very low cost. And then on the bottom, we have your ability to provide any unique experiences associated with blockchain data. As you come to the right, something like subgraphs, you start to be able to do more advanced features. And when you bring in a custom index, right, that becomes very costly. But we're starting to provide you the tools to make that as simple and inexpensive as possible. So thank you all for coming to my Chad talk. And if you want to follow up and look into any further information, here's a QR code for streams as well as functions. Thank you all.
Well, aren't we lucky to have so many awesome speakers today? I am very excited to announce that we also have Manu from Block Ravers coming in to talk about the rise of the Trust Network. Can we all give Manu a big round of applause? Yeah, I like you in the back. Good.
Hear me? Okay, now. All right. Yeah, welcome everyone. I'm going to talk a little bit about trust networks and what I'm seeing, how basically trust is evolving with the rise of blockchains. And let's wait a second maybe until we get the slides on. All right. So yeah, I'm Manu, and I'm one of the founding members of Block Ravers. So first of all, let's talk about trust. What is trust? Trust, this is what I just asked ChatGPT quickly just to tell me. Trust involves a willingness to rely on actions, words, or decisions of another party with the expectation that they will behave in a reliable, honest, and a competent manner. So for me, trust, the way that I see it, is that sometimes, like if we're in a known place and we want to go to an unknown place, we have to ride into a lot of uncertainty. And for us to get from that known place to that unknown place, we need to have some sort of trust. Whether it's trust in the machine that is taking us from the place A to place B, or whether it's the person that is connecting us with person A to person B, we always require trust in order to move from one place to another. So I believe that trust is the lubricant for society. And why is that? Because I think that the main drivers of trust are for people to feel that they can trust in someone, or they can trust, let's say, on an institution or something. There has to be first competence, that you believe that they're able to do what they say that they could do. The second one, authenticity. And that means that they experience that you're real, or that that organization is real. And the other one is empathy, that basically that the organization or the individuals, that they show that they care about your success, that they care about your well-being. And without any of these three elements, basically there wouldn't be any form of trust. So how can we increase trust in our society? Humans, we have created different protocols. A simple protocol that we do is shaking hands. Another protocol that we do is clink cups and say cheers. Do any of you know what's the story behind clinking glasses? No? Okay, so basically what happened when the monarchs received someone that visited them, and they brought, let's say, some wine or brought something to drink, they would pour something in the glass of the person that brought the wine, and they will drink it first before the monarch. So as a show of trust, if the monarch trusted the person that was bringing the wine, rather than making them drink, they would clink the glasses and then drink together at the same time. So that evolves as a form of saying, I trust you. And basically, we humans, we have been incorporating all of these different protocols for creating trust. Another one, recent one, people doing pinky promises and just putting their pinky fingers around. So one thing that I learned about trust, thanks to this game, that I encourage you to scan this QR code and play this game whenever you have time, to understand how trust evolves in society and how trust evolves with different players in this game that we call life. So some of the learnings from game theory is that for trust to increase, we need to have repetitive interactions. And for that also we need to have, or we need to create possible win-win situations. And we need to reduce the opportunity for miscommunications. And by doing this, we basically can increase trust. And why am I talking about trust? I'm talking about trust is because we are creating trustless protocols in a society where trust is needed. So yeah, trust has evolved over time. So imagine when we were at Thrive, or when we were not, let's say, necessarily living in big cities. First, we had a form of trust where it was local, person to person, peer to peer, individual to individual within a tribe. Then, when we grew too big, we needed to delegate that trust because we couldn't rely on the trust person to person anymore. So we had to have something that we call the institutions to basically behave as a proxy for trust. So they will enforce, let's say, some rules into the population, and that will generate some trust within this new society or with this form of humans that are coming together. The thing is that most of these institutions, the way that they've been built, they're very opaque. And right now, many of us don't trust any of the institutions. People don't trust governments anymore. People don't trust religion anymore. People don't trust pretty much any institution. We don't know what's real anymore. And with the rise of AI, even more. What is real? Is it basically what the people that have money that are able to use, let's say, AI and create different narratives and create different stories? Is that the new real? Well, now we need to question more and more what trust is and how do we create trust in this new society. And I think the way of doing it is by creating, again, peer-to-peer, going back to the roots, one-to-one in a distributed manner. And that's what I call the rise of trust networks or distributed trust networks. So if we talk about the institutions are very opaque, very close, centralized. Usually they're licensed, they're top-down, while distributed, let's say, forms of trust should be transparent, inclusive, decentralized, accountable, and bottom-up. But many people in the Web3 space, they think that we are in the distributed side, while in reality, we're not there at all. We're way more in the institutional side. Why? Well, ask around. Most of the DAOs are very opaque as well. Not necessarily because they're a DAO, they're open and transparent and actually doing, let's say, something good for the community, but rather enclosing and centralizing and making decisions closed door most of the time. So I really, really believe that the future is actually to create new systems that are that the trust is distributed among different participants. So now in this age of platforms, we need, if we want to go to a known place to an unknown place, and we are, let's say, in a marketplace, for example, if we are in a marketplace, you need to trust the other user that you're interacting with. You need to trust the platform itself. You need to trust the idea. And you need to trust many other things that people sometimes don't question themselves. And you need to ride on all this uncertainty. So, as I said before, we are creating trustless systems, but hey, they are not completely trustless. You still need to trust. You are trusting the systems, actually, that you're using. So, if we talk about trust, what trust is needed? So if we talk about, for example, I'm originally from Venezuela. So if we want to talk about Bitcoin being used in Venezuela, we need to rely on first having energy. Sometimes we have 8 hours without energy. So damn, how can we transact with that network if we don't have energy? We still need to rely on the trust of having energy. We need to rely on the trust of having hardware that will run this software, consensus mechanisms, the different tokenomics of the different projects that we're using, the regulatory environment that we're trusting, the oracles and the data that we're trusting, the different security elements that are being implemented for safeguarding the different protocols. The privacy and anonymity of the protocol, do they really have it? Also, the community trust. The protocol trusts itself when it comes to emission of different incentives. You also are trusting the core team of the different projects that you're using most of the time. You're trusting the DAO, or you're trusting the whales, or you're trusting the stakeholders, or you're trusting many different people. So as you see, this is not a trustless system as everyone talks about. Mostly it's a lot of marketing. So we need to rethink what the heck is trust, because trust is very complex. So yeah, very complex. So why trust is important to Block Ravers? So for those that don't know what Block Ravers is a community that has been for the last 5 years traveling the world, having fun together with friends. And we have created a group that is self-curated. And we're going to talk a little bit about the experiments on how we got until what it is today. So yeah, I started back in DevCon Osaka in 2019. And in 2022, we had already over 500 people wanting to join the group and just to party and enjoy the community that we have been creating where we trust each other. So in East Denver in 2023, last year, we did a party, and in that party we invited only people that we vouched for to the party. And the people that were vouched for the party, we were asked to the voucher, hey, do you really vouch for this person? And then if they say yes, we will accept them, and then they will be able to come to the party. Why? With the idea of creating, let's say, some sort of accountability of who is inviting the different people to our party. So somehow one day we're partying, and then at the end of the party, we come and we see a wall, and there's a graffiti on the wall, and we're like, damn, this was an Airbnb, so we had to pay for that. And we're like, okay, how do we do it? Well, we started looking at the different people that were that night with us, and we sent a message in the group, hey, somebody did a graffiti, and then somebody sent us a DM and said, hey, actually, the person that made the graffiti, I heard that it was a friend of mine, and I will take responsibility of it. I will pay for it. I will do whatever it takes to making it right. I don't want to be kicked out of the community. The guy was supposed to go to Breckenridge together with us and stay in the same house. So he was scared that we were going to kick him out for inviting someone bad to our community. So he was, coming out there and saying, you know what, I'm going to take responsibility of this. So we realized that this is actually super interesting, how we can create systems where the community members are accountable for each other. We don't need someone to police us if we are all having trust between each other and we are all observing how we are all behaving. So in Susalu, we did something, we did an experiment. We told people, if you want to come to our party, come and meet us in person, and we're going to give you a Venezuelan bolivar that has no monetary value, but it has something that makes it very unique, and that is the serial number, and also let's say the different things that the bill has to make it unique, so you can see it against the light and so on. So if you think about it, the bill is kind of like an NFT. It's a very unique, very, very unique, let's say, object that is difficult to falsify, let's say. So we say, okay, come and meet us in person, grab the bill, and instead of me giving them an identity and saying this is you, you're gonna come with the bill and you're gonna take us a picture with the bill and you're gonna say this is me. And basically we created like a social graph with all the serial numbers of the different people that were connecting with each other. So for the people to be able to come to our party, they had to have 3 vouchers. So people within the community, they had to vouch for each other. So once they achieve and they had 3 vouchers that they were cool vibes to come to the party, then they could come. And we started doing these experiments and these games. Why? With the intention of creating some form of accountability within the community. We also had this type of system where if someone that you invite, let's say, harass a woman or does something bad, that person that is harassing gets kicked out, but the person that invited them gets a yellow card. And then on the second yellow card, they also get kicked out. So basically, we are creating like systems or ways of creating accountability within communities. And we need to start focusing on that IRL and also obviously online. And yeah, with this experiment, we actually won the hackathon in Susalu during the Public Goods Week. At SuConnect, we did another experiment. Together with the Ethereum Foundation, we work and we did something that was called Job Mojis. Job Mojis was literally just an NFC card that had a counter inside the NFC card, and every time that you will come with your phone, you will tap it, and it will generate proof that you met the person in real life. And that proof was unique because of the counter that it had. Every time that another person will come with their phone, the counter will go up, 1, 2, 3, 4, and then it will generate a new signature every time. So like that, you could create, let's say, snapshots of all the different people that you're connecting with, and then you can start saying, okay, I trust that guy a little bit when it comes to, let's say, math, because he shows me that he resolved a mathematical problem, or let's say I trust the other person in cryptography, or I trust the other person when it comes to marketing and stuff like that. So you can start creating a social graph where you define what are those different elements of trust that you have in different individuals. And then you can also start revealing part of your identity to those different individuals. Let's say that I get to know you for the first time. I might give you only my email, my Telegram. And then if we start developing a relationship, I might give you, let's say in a week, I might give you my Instagram. And start revealing more parts of my identity with zero knowledge proof. And basically, I can start removing or creating different accesses to people that I trust. And not only that, I can also connect, let's say, people that trust me. I can create kind of like a social graph that will enable me to connect with my friends and their friends and the people that they trust. So like that, we can create new systems. Let's say the couch surfing model, where people were going to different couches and staying at different places, also like Airbnb models. We can do so many new forms of trust networks that are actually decentralized. So block ravers in the future. What is block ravers in the future? Well, the last few months, I've been understanding more and more that trust is so complex that even though I've been studying and analyzing a lot, I'm still failing. I'm still failing in identifying, let's say, patterns that make me, let's say I shouldn't trust this person or I shouldn't trust that other person. I'm still making mistakes all the time. And I'm sure we're going to continue creating mistakes all the time. But yeah, I believe that in the future, the way that we're going to create these new systems of trust has to be with this social graph of people, peer-to-peer, and also it will be very contextual. If we start putting a number to trust, then basically we're going to fall into creating a social score, which is not necessarily what I'm advocating for. What I'm advocating for is creating, let's say, different forms of social graphs that are very contextual, and it will depend on each individual, and each individual will decide who are the different persons or who are the different, let's say, oracles or APIs that they trust. So yeah, that's basically what I came to you to talk about, trust networks. And if you want to learn more, please reach out. And if you want to be part of the Block Ravers crew, scan this QR code. That's it. Thanks, everyone.
I'm still seeing some very familiar faces out there. You guys are really enjoying the content today. All right, so we're really lucky to have Lila from CoinDesk back up, and she's going to be joined by Chris of the Near Foundation. Everyone, let's give him one of our great round of applause as we've been doing all day. Louder, come on. All right, awesome.
Hi, guys. So I have Chris Donovan with me, who is the COO at the Near Foundation, and also General Counsel, correct?
That's right, yeah. Hi, everybody.
So today we're going to be speaking about chain abstraction. So Chris, if you could start us off by giving us a brief background, and then maybe we can go in a little bit more depth as we progress.
Sure. Hi, everyone. I'm super jet lagged, by the way. I arrived
both
from
came
Switzerland,
from
so I'm kind
Europe.
of amazed I'm awake, even. So chain abstraction. Right, well, for us, it is all about a vision of abstracting away the current complexity in blockchain environments, particularly multi-chain blockchain environments, where right now, users need to be maintaining multiple sets of private keys, multiple wallet clients. They need to be thinking about bridging and managing gas fees, all of this kind of stuff, which is a real barrier for adoption on the user side. And I like to think, could my grandma do this stuff? And right now, absolutely not. I mean, she's actually pretty tech savvy for a 98-year-old, but she couldn't handle this. And then on the developer side, right now, when developers are choosing where to build, they have to make a bunch of trade-offs, and they're subject to lots of different constraints because we're in a pretty modular state and a fragmented state in Web3 right now, and that means that, resources like users, like liquidity, like particular kind of types of dev tools, for example, are kind of siloed in different places, and so when you make a choice about where to build, you typically are sacrificing one or more of those things, and our aim is therefore to try and unify all of these different disparate silos together, kind of like a connective tissue, so that developers don't have to make those types of trade-offs anymore.
Thank you. And maybe we could break down a bit more what the issue is here that you're trying to solve. Where are the specific pain points, and how does chain abstraction / near fit into that?
Sure. So maybe starting with thinking about the current state of the industry, and I mentioned just in the previous response that we're in a very kind of modular state right now. We have a bunch of disparate ecosystems, but then we also have projects that have actually been breaking up the blockchain layers themselves, settlement, execution, data availability, into separate kind of modular offerings, which is great for scalability, but it creates that fragmentation that I mentioned, both for users and also for developers. And in our view, if we want this technology to be being used by billions of people, we can't have the infrastructure being a barrier to adoption. So what we're trying to do is just remove as many barriers to adoption as possible, and also at the same time help all of us as members of this industry collaborate a little bit more effectively together. I think tribalism is something that is typically can be quite fierce in our industry, and I think it is in a lot of nascent industries in general. People feel like they really have to have sharp elbows, really competing over a small slice of the pie. But actually, our view is if we can move past that mindset, but also help create the technical substrate that makes collaboration easier, it'll be better for the industry as a whole.
And what makes Near specifically the best to facilitate this?
Well, that's a great question, and maybe I'll start at a higher level, not thinking Near specific, but just more kind of the general technical features and innovations that you would need to enable the chain abstraction future. And so the first thing is, what we need to have is a unified security layer between different blockchain environments. And by that, I mean, if you think about the state of the industry prior to zero knowledge, for example, right, you would need to rely from a security perspective on a bunch of decentralized validators to maintain the state. Whereas now with zero knowledge, you can actually, you can prove the state of a particular chain, on a single server, right? So you do not need to be relying on disparate groups of decentralized validators in all cases, which means that for developers, who historically would have had to choose between either operating on a pre-existing shared large chain infrastructure or even building their own chain, which is expensive and complicated. Now they can actually just spin up a chain running on a single server, and they can use zero knowledge proof to actually, publish the proof on another piece of blockchain infrastructure. So that's the unified security layer. We then think about what we call the identity layer, and this is the ability for users through a single account to actually transact and control multiple addresses in multiple different blockchain environments. And so in the NEAR ecosystem, we're working on something called account abstraction, which productizes that vision. And in practice, that means that from your NEAR account, you can actually sign transactions and control assets in a whole bunch of different blockchain environments. Like, so, if you've got Bitcoin you want to move around, you've got stuff on Ethereum, whatever, you can do that from your NEAR account. Which we think is super powerful because that's one of the biggest barriers to adoption right now. And then the last piece at a high level is what we call the experience layer, which is effectively from a user interface perspective. Do I need to be jumping in and out of different environments, different applications? Am I going to centralized exchanges? Am I going to DEXs? Am I going to different dApps? Or can I do all of this from the same user interface? And we think that it needs to be the same user interface because right now, Web2 experiences kind of do that for you, right? And it's the convenience and the ease of use is kind of what's helped Web2 scale and be so successful. And if we want to match that and we want to get to the same levels of adoption, we have to kind of meet them on the same terms from a kind of convenience and usability perspective. But then talking specifically about NEAR, and I'll caveat all of this by saying, well, two things. One, we view chain abstraction as a collective effort. So there are lots of places that chain abstraction is being worked on, and we're just one of them. And we think that's great because we want lots of people trying to solve this problem because it's so important for the industry. The second caveat I will give is that I know my way around the technology, but I'm not deeply technical. I used to be a lawyer. I'm a reformed lawyer. But I'll do my best to walk the group through the kind of different technical pillars in the NEAR ecosystem that we're working on right now. So there are three pillars, basically. The first is what we call account abstraction, which is actually a native feature of NEAR accounts since the protocol was launched back in 2020. And what that basically means is that NEAR accounts map to human-readable addresses. So Lila.near, Chris.near, for example, rather than a public key hash. So effectively, accounts are like smart contract containers on NEAR, and you can put as many different keys as you want within that smart contract, and those keys can have different permissions for different things, which creates quite a versatile account environment. And it's also typically gives you more security and granularity as well. And one of the cool features that we launched last year that was kind of a stepping stone to this vision is the onboarding experience called FastAuth, which basically allows users to create a NEAR account in less than a second, and it's secured using biometric passkeys, and it basically matches that Web2 account creation user experience. It's super fast, it's super slick, and all of the blockchain stuff happens under the hood, and users don't have to know that it's even there. And again, that's kind of part of the vision of chain abstraction. So that NEAR account model is one pillar. There are two others. One is chain signatures, and that is the ability through MPC nodes in the NEAR network for NEAR accounts to control and sign transactions on other remote accounts in other blockchain ecosystems. And that's the really big innovation. It's also the most complicated piece of the puzzle as well. But again, for us, that's how you get to that state of, one account to do all of your Web3 stuff. And that's the sort of simplification piece. And then the last component is what we're calling intent relayers. And this component is designed to effectively transfer and execute based on the intent of users and abstracting away the underlying complexity. So when you traditionally transact on a multi-chain basis, like I mentioned, you've got to manage all of these different keys and wallets and bridging and all this kind of stuff, gas fees in different native tokens, which can be super complicated, right? Even I find it difficult sometimes, or I find it so tedious that I just don't bother because it takes too long. And so the intent relayer, what it does is it helps to eliminate particularly the management of gas and the kind of exchange of tokens on the destination chain. It kind of captures that process. And so for us in V1 of account aggregation, what happens is that the near accounts, rather than mapping directly to these remote addresses on different blockchains, they actually map to the intent relayer, and then that relayer then controls the remote accounts underneath, and the relayer, I guess it kind of processes all that transactional complexity on behalf of the user. And again, I think if you can't solve that, then again, you're not really giving users that seamless multi-chain experience.
You made the point of, we spoke a little bit about user experience. I'm wondering if you can compare the way that this would look to something that we may use already in Web 2. I know you said you're going to be able to move assets from whether it be Bitcoin, Ethereum, or your near tokens.
Yeah.
How would that look in terms of the app?
It's a great question. So I think, well, first of all, it would mean that, right now, if you want to transact on a multi-chain basis, you're coming in and out of a bunch of different application environments. And that's not just wallets, but it's also sometimes, centralized exchanges if you want to do kind of transacting in real time on a multi-chain basis. Right now, that's just about the only place you can do it effectively. So in a chain abstraction world, you would do everything from one place, first of all, which is great. Secondly, you would not need to think necessarily, unless you wanted to, and sometimes there's good reasons for it, but generally you would prefer not to have to bridge assets at any time. Because bridging is a real pain in the backside. It's also a huge security risk, and it's also quite expensive. So now, because you're able to control these remote addresses in these assets on their native chains, you don't need to worry about trying to bridge and wrap and all that kind of stuff.
But the user isn't going to see that back-end stuff. I just see that my assets are moving.
So for example, maybe like to give a use case example, let's say I own a Bored Ape NFT on Ethereum, right? And I want to sell that on OpenSea. I would do all of that from my near account. I'd see my Bored Ape NFT in my near account, in my kind of wallet experience on the near blockchain. I would be able to set up the sale, set the sale price, press execute, and then all of the components, and there's quite a few steps that happen under the hood for that. Like you've got to consider preparing the ETH payload for the costs of transacting on Ethereum, for example. And that all happens under the hood. And as far as the user is concerned, I've sold my Bored Ape, I've got my ETH profits, and it's all just happened in one place.
Okay.
And we think that's like an enormous user experience change from what exists today.
Absolutely. So I think I understand from a user perspective what chain abstraction means, but if I were a developer, how does it benefit me?
Okay, well, lots of different ways. So let's take, for example, a feature of the Near ecosystem right now. So one of the things we've been pretty good at, I think partly because we've always, since the protocol's inception, we've been trying to abstract away complexity, like make adoption easy. So we've managed to attract a lot of monthly active users to the ecosystem. We have about 14.5 million monthly active users in the Near ecosystem right now. And for developers not in the Near ecosystem, that pool of users is really valuable potentially, right? That's potentially like a gold mine of user traffic and user interactions, new customers, all of this kind of stuff. And with chain signatures and account aggregation, if I'm building a dApp in a different blockchain environment, let's say Solana, what I can do is in my wallet selector page, I can add sign in with Near, and then my users can actually my project then gets access to all of the users in the Near ecosystem as a result, right? Which is super powerful. But the same goes for things like access to liquidity too, right? So if I've got I don't need to think about picking an environment because it happens to have liquidity for the use case that I need. I can access it from anywhere now, which means that I don't need to compromise and I don't need to think, well, I'd rather build over there because I think the developer toolkit is much more efficient and effective for me, right? But all the users are over there and all the liquidity's here. And so how do I kind of square that circle and deal with the trade-offs? I don't have to do that anymore.
Okay, great. So what is this? You mentioned briefly that this might remove the necessity for bridges. What does this then mean for bridging?
Well, I mean, it doesn't eliminate bridging entirely. There are sometimes good reasons why you might want to bridge assets. So for example, like Ethereum is not a bad example. Ethereum is pretty expensive to move around on Ethereum. And if you just wrap it and put it on another chain, you can then move it around much more cheaply and efficiently and sometimes even more quickly. But in general terms, and I think if you speak to folks, that are deep in the industry and deep in the ecosystem, bridging is, like I said, a real pain in the backside, and bridges are always just terrible user experiences, and typically also they're massive liability vectors. Like, they're where, if hackers are on the prowl, that's what they tend to focus on. They tend to be really big honeypots. They have lots of liquidity trapped in them. So again, because you're not needing to worry about pulling assets from their canonical native chain, you can just move them around. You're controlling them from over here, but they're staying in their local environment. You don't need to worry about bridging anymore, and that makes it faster and also cheaper and more secure to do the transactions that would otherwise take you like 15 steps and 2 hours and cost a lot in gas fees and exchange fees and all of that kind of stuff.
Okay, great. In terms of interest and adoption for this, I know it's fairly early stages, but what have you experienced and what are you seeing so far?
Yeah, so we had our Chain Abstraction Summit yesterday, and I don't know if any of you went, but we actually had one of the first demos of chain signatures in action. So Sweat Economy, which is one of the biggest projects in our ecosystem, which is a move to earn protocol. You take steps, you earn tokens, which is great. They actually demonstrated a feature where users can transact and settle on Binance Smart Chain from their Sweat wallet, which is a near account based model.
Okay.
And we have a few other projects. So we have Cosmos Kaiching, which is like a shopping loyalty environment. And they're actually a really interesting case because they moved from a Web2 payment rail structure, so Stripe, to the Near protocol to save on transaction fees, because Stripe charges a pretty high transaction fee, and also is not particularly fast relative to the Near protocol. So they're exploring chain signatures to broaden access for their user base to other ecosystems, other liquidity, other opportunities. And we also have Play Ember, which is a hyper-casual mobile gaming project. They have millions of monthly active users as well, and they're also hoping to broaden the experience environment for their users by implementing this technology.
Cool. What sort of challenges have you faced when trying to push this forward and get people interested? Have you noticed that there's competition? I know you mentioned earlier that this isn't a competitive thing. Everyone should be on board, and it's like you play for each other. But how does that look from your side of things?
Sure. Well, I think, first of all, just from a technical implementation perspective, like this stuff is pretty hard. And people have been trying to figure it out for a while, although, as I said, we feel like a lot of different pieces are coming together in quite an exciting way right now. And we do have stuff that's live on testnet. We have documentation around account abstraction and chain signatures that, if anyone's interested, I encourage to go look at it. We've got some Telegram groups with developers that are specifically thinking about and working on these topics, which is great. And these are people from loads of different ecosystems, which is amazing. So the technical side is hard, but we feel solvable. I think the bigger challenge, interestingly, has been helping people change the way they think about operating in Web3, like from this tribal mindset of my chain is the best chain and I'm competing with all of you to let's work together to solve this collective problem, and it's genuinely mutually beneficial. Like if we connect all of these things together, it's a better environment, like I said, for users and developers everywhere. It doesn't matter where you're building, doesn't matter where your users are. It's a better experience, and if we want Web3 to be being used by billions of people around the world, which is definitely our aspiration, we think you have to have this stuff.
And Do you think that other chains have that perspective?
I think I think it depends on who you ask, right? I think some folks absolutely, and definitely we've noticed a desire, perhaps during the previous bear market, and as we move into this new cycle, of folks just wanting to be more open and collaborative in general because they recognize that, you know, rising tide lifts all boats, and we might as well help each other try and be more successful. But then equally, and this, by the way, includes folks even in the near ecosystem, there are folks who kind of say, well, hang on a minute, I want to bring these people to build on the near protocol. I don't want them to be over in Solana or whatever, and we have to try and help them view those other ecosystems not as competitors, but as collaborators. And that's, like, being honest, it's just going to take time.
But you can see that it's improving from where it was.
I think so, and I think the use cases help because it feels a little bit magical to, you know, to kind of go from this painful user experience to just like a couple of clicks and it all just happens under the hood. Like, really, it feels magical. It feels similar to how it feels when you use these things, and everything is just so seamless, and you're kind of even I'm still occasionally astounded by how easy or how kind of magical even the user experience can be. And I think we're just beginning to have the building blocks to begin to replicate that in Web3, and that will just help people see the benefit.
Wonderful. That's all we have time for, but thank you so much, Chris. Appreciate
Pleasure.
it. Thanks, guys.
Thanks, everyone.
I do this with
Hello again. I know you guys are so excited to see me back up here. I am so pleased to announce that our next speaker is Oren Katz of Starkware, talking on the next phase of scaling. So everyone give a huge round of applause.
Hello. So I'm Oren from Starkware. And I want to share with you, I want to present the proving technology we've been working on for a while now. So I'll both start and end with these highlights. So it's going to be the fastest proving technology out there. It will significantly reduce the cost of generating Stark proofs, and it's going to be seamlessly integrated into StarkNet. So if you're using StarkNet or building on StarkNet, you're going to reap the benefits of this without the need to do anything. So what I'm going to do is first I'm going to explain why or how proving technology actually helps with scaling blockchains. I'm going to run briefly through the history of proving and its relation to blockchains. Then I'm going to introduce this new prover we're working on. I'll briefly touch a few of the improvements or the mathematical enhancements that make all this possible, and then I'll end with the benefits of all of this. So why do we have a scale issue with blockchains at all? So blockchain is a decentralized technology. So you have lots of full nodes, typically tens of thousands or even more. But each and every one of these full nodes really has to execute all the transactions of the entire network. Add to that we want a full node to be able to run on a weak machine, and we end up with us limiting the throughput of the network so all of this could actually work. That's basically why we have a scale issue in blockchains. So how does proof systems, how does Stark or other proof systems actually help with that? So the main idea is simple. We want to take all of this computation of running all the transactions off-chain. There we could actually only run it once. In addition to running it, we'll also generate a proof, a Stark proof, that basically shows that all these transactions were valid. We're going to send that proof on-chain, and the only thing we're going to do on-chain is basically verify that that proof is valid, instead of running all these transactions. And the nice thing about Stark is that verifying a computation is a lot less expensive than actually running the computation. It's exponentially lower cost than actually doing the computation itself. And this is the way how we can run lots of transactions off-chain, but still verify them inexpensively on-chain. So based on this idea, we came out with this concept of layer 2 validity rollups. And the way this works is that the users send the transactions, instead of sending them directly to layer 1, they send them to layer 2, or more specifically to a sequencer, which is running a layer 2. This depicts StarkNet, but it's true for any other validity rollup as well. The sequencer sequences these transactions into blocks. These blocks are then sent to the prover, to a Stark prover, that generates a proof that shows that all the transactions in these blocks were indeed valid. That proof is then sent on-chain to a smart contract on Ethereum that knows how to verify Stark proof. And when that contract verifies the proof, only then can we basically update the state of the rollup on another smart contract on Ethereum. So this is where we're able to run much higher throughputs than Ethereum can handle without compromising the security of the base layer, which is Ethereum in this case. So this concept of proof systems is not really new. It's been known in academia for several decades. Even the later enhancement of that, which is zero-knowledge proofs, was already published in the 80s, in 1985. But for many years, it's been something that has been researched, but not really used anywhere in any industry in production, because there simply wasn't a use case that people thought warrants that. Things started to change once blockchain came around. So first there was Bitcoin, then Ethereum. The first time zero-knowledge proofs were actually used in production were in Zcash in 2016, and then they weren't used for scalability, but rather for private transactions, so for privacy. A couple of years after that, the Stark paper were published. Stark is the proving technology that we use. It has some better qualities than the ones that came before it. And also Starkware, the company, was incorporated. And 2 years after that, we deployed our first rollup on Ethereum mainnet. That was StarkX. StarkX is an application-specific rollup that caters for a specific family of applications, which is crypto exchanges. So it supports spot trading, NFTs, derivatives, but it already was able to show that we could run a much larger number of transactions on Ethereum at a much lower cost. And there are multiple exchanges actually running on that technology. A year after that, we deployed the first alpha version of StarkNet. StarkNet is our general purpose smart contract platform, so it's more like a full blockchain running as a layer 2 on top of Ethereum. I just mentioned both of these. Underneath the hood, we're running our Stark prover that we called Stone. Stone stands for Stark 1, which is the first prover that we've developed when the company was founded like 5 or 6 years ago. So all of StarkX, all of StarkNet up until today is running on that prover. Here you can see some numbers for StarkX and StarkNet. As you can see, they're big. I'll highlight some of them. So if you look at StarkX, StarkX has facilitated to date, in terms of trading volume, it caters for exchanges, so traded volume of over $1.2 trillion. The number I like most is the one on top. If you aggregate the amount of saving that StarkX and StarkNet has saved in gas costs on Ethereum to date, that's all by itself over $1 billion. So if somebody wanted to run all these transactions on Ethereum, it would have cost $1 billion more than it did. This is another nice metric for StarkNet that shows the size and the growth of its developer ecosystem. So StarkNet, what you see on the x-axis is basically the number of developers working on StarkNet in Q1 2020, and the y-axis is Q4 last year, Q4 23. And you can see StarkNet over there. Not only is it the biggest ecosystem outside Ethereum, it's also the fastest growing one. And this is basically due to the strength of the technology and the strength of the community. Okay, so what's next? So like I said, all this was running on Stone. Stone is basically a prover that we've built 5 years ago, even more. Now the world has progressed and we know how to do things better today. So I'm very glad to introduce now the Stu prover. Since the first one was Stark 1, it only makes sense that the next one is going to be called Stu. Now it incorporates several enhancements and improvements and advances, basically improving technology. I'll mention them. I'll touch briefly some of them. I won't have time to go over all of them. So it uses a small field, the Milsen31 prime field. In order for us to be able to run Stark on top of that field, there's this new invention called Circle Stark. I'll talk about it a bit in a second. It also uses GKR lookups, mixed degree traces, and also some improved Cairo virtual machine. I won't be able to touch all of them, but if you're interested, come and talk to us afterwards. So what's the Milsen31 field? So it's a prime field, where the prime is exactly 2 to the power of 31 minus 1, which has some neat properties. So first of all, it's small. That's what makes it good for performance. It's less than 32 bits, which make it pretty granular for arithmetization as well, which is what you do in Starks and proof systems. It has this nice property in modular reduction in that 2 to the 31 in that field is exactly equivalent to 1, which makes computations easier. And it basically offers great performance for both CPUs and GPUs. But there's a problem here. So the field is great, but if we want to run Stark on top of that field, we need another thing. We need the structure of a group over that field. And for Stark to function properly on that, the group has to be of size that divides by high power of 2, things 2 to the power of 30. But Milsen31 doesn't have that. The highest power of 2 it divides by is actually 4. Is actually 2. It doesn't even divide by 4. So luckily, there is a solution to that, which a few researchers from Starkware published a couple of years ago. That's called ECFFT, elliptic curve FFT, that basically enables us to run Stark on top of a group that doesn't have this nice property, on top of a field that doesn't have this nice property, because the group we build is not the generic multiplicative group, but rather an elliptic curve, a group built on an elliptic curve. But there's another problem here, that the elliptic curve operations are expensive. So we can use it for Stark, but it'll be quite inefficient. So now there's a bit better solution. This is an article that was published just 2 weeks ago. It's a collaboration between Polygon Labs and Starkware. And basically it introduces a new type of group that we could use for Stark that actually has better performance, and that's called Circle Stark. So I'll start by showing a short movie about Circle Stark.
Well, you know me, at least better than this name. Doesn't he think I'm an imbecile? You're biased. Your fellow wants it. But let me ask you a question. What an imbecile? This is sweet.
Can you hear it? Hardly. Okay. Okay, so first a couple of apologies. The next few slides are going to be a bit mathy, so I may be losing some of you, so it's not going to be long. Bear with me. Another apologies to the ones who actually want to dive deeper into the math. This is going to be more hand-waving than rigorous, so if you want to hear more, come and talk to us afterwards. So there are many types of groups. The simpler one is what I call the generic multiplicative groups for prime fields. It's basically all the integers up to the prime minus 1 with multiplication, which actually forms a group. Like I said, this is the simplest, but it doesn't work well for Sen31 and Stark. So the other option I mentioned before was, instead of using integers, we could have each group element basically be a point on an elliptic curve. And then we use the elliptic curve multiplication for the group operation. That's also a group. That actually does work for Stark, but is quite inefficient. And this new idea is, basically we could use another curve, which is just the circle, or basically the unit circle. So the group elements are basically points on that circle, and the operation is pretty much angle addition. So if you want to add 2 points on the circle, on the curve, so each point corresponds to its angle. So if we want to add the point that corresponds to angle A with the point that corresponds to angle B, what we get is basically the point that corresponds to alpha plus A plus B. And one can show that this is indeed a group, and it's a group that's very simple to actually do Stark operations on, and FFT, and all that we need for this. And from a Sen31, it has exactly 2 to the 31 points. Okay, so what's in it for you? So first of all, this is going to be a lightning fast prover, way faster than anything out there today. How fast? So we're not done with it yet, but we estimate it's going to be more or less 100x faster than Stone. And for StarkNet, so first, like I mentioned before, it's going to be seamlessly integrated underneath the hood. So for whoever is using StarkNet, building on StarkNet, sending transactions to StarkNet, you don't need to do anything, and you'll get the benefits of this. It's going to lower the fees because it's going to cost a lot less to generate the proofs for the transactions of the network, a lot less. It's going to improve the finality, both on layer 1 and layer 2. For a similar reason, because it's going to take a lot less to generate a proof, so we could submit it a lot quicker. And as always with technological improvements, it opens new possibilities, some of which we probably haven't even thought of until now. Just to get you thinking, consider that today, generating a block on StarkNet and typically on networks is something that takes a few seconds, maybe up to 10 seconds. Whereas to generate a proof for a block is something that takes a lot longer, something like 10 minutes. Now imagine what would happen if generating a proof will take also the order of magnitude of 10 seconds, which is the same time it takes to build a block. What that means for consensus, what that means in general. And last but not least, all of this development is open source from day one. So if you want to take a look at it, so we're not done. It's still work in progress. It's still early stages, but we already have some code and a working example of a simple proof for a Fibonacci series. So you could scan the QR code and go to the GitHub repo and take a look at it. So I'll end where I started. This is going to be the fastest prover out there. It will greatly reduce the cost of computation of generating Stark proofs, and it's going to be seamlessly integrated into StarkNet. Thank you.
Hello, hello. I hope you guys are enjoying soaking up all this awesome content. I am very proud to announce Michael Bentley on the evolution of lending protocols. Let's go give him one of those rounds of applause that we're so good at.
Hi, everybody. Wow, that was loud. Yeah, thanks for coming to see the talk today. Yeah, I'm Michael, one of the co-founders and CEO of a company called Euler Labs. We started back in 2020 in the midst of the pandemic and built a lending protocol called Euler that, as far as last year, was one of the third largest lending protocol on Ethereum. And yeah, very excited to be back in 2024 with a brand new version of our protocol, which I'm going to get to a little later on. So today I'm going to tell you about the fundamental design and building blocks of a lending protocol, and particularly how lending protocols work on Ethereum today. I'm going to take you through a little bit of a history of where things started, going back as far as 2019, and take you all the way to the present day, where we'll cover a little bit about how Euler v2 works and why I think it's one of the, I think it's the best lending protocol on Ethereum this year. So, thanks. Yeah, by the end of the talk, hopefully you'll understand how lending protocols work, why they work the way they do, and we'll go through a lot of the trade-offs in the different designs. So first things first, on-chain lending, what is it? It's a mechanism to allow lenders to deposit assets and earn yield on those assets. Pretty much all on-chain lending is over-collateralized. I guess that's kind of atypical in traditional finance. A lot of lending, in everyday life tends to be uncollateralized. But on-chain, it's really important that things are over-collateralized. A great example of this in traditional finance would be a mortgage, right? You typically put down more collateral than the value of the loan that you've taken out. So if you're buying a nice house like this one here, you would have more collateral than the loan, like a mortgage. Why is uncollateralized lending not going to be a topic of this talk? It's just not very common on chain. There's no way to really enforce that loans will be repaid. And so whenever we see uncollateralized lending, especially when you don't have really good, strong legal frameworks to support them, bad things happen. So we're going to see a lot of these kind of diagrams today. I'm going to take you through the building blocks of a lending protocol. And we can see on the slides here, these little diagrams are going to indicate to us what's being used as collateral. Will always be the thing with the little circle. And the thing that's being borrowed, where the lenders are, is going to be the end with the arrow. And really the question we're going to be exploring is how many different ways can we draw this diagram, and what are useful ways to draw this diagram. And we'll start from the beginning and work our way up to some really hairy kind of stuff and explore some of the trade-offs. One really important aspect of these diagrams is whenever there's rehypothecation, that essentially allows the thing that's being used as collateral will also be being lent out at the same time, which means that you're able to earn yield when you're borrowing something. So you can either just deposit collateral and hold it in a vault, and that will generate no yield, or you can deposit and simultaneously lend it out to other people and earn yield, and that reduces net borrowing costs. So that'll be an important part as we move forward. So yeah, going back to the sort of start, I think the earliest on-chain lending on Ethereum, at least, going back to 2017, was ETHLend, which was the precursor to Aave. I think this was actually a nice project. It never really took off, and it was perhaps ahead of its time, but essentially this was over-collateralized loans mediated by smart contracts, where borrowers and lenders had to kind of find one another and then come to agreement over terms of a loan. The project really never took off because the system was too fragmented. When you do peer-to-peer lending, you have to agree on how much to borrow, interest rates, loan terms, and so on. And the system's very fragmented and inefficient. So shortly after ETHLend came out, we saw the emergence of the first peer-to-pool model. This was made famous by Compound. And rather than in peer-to-peer lending where lenders and borrowers need to find one another, in peer-to-pool models, lenders deposit assets into an aggregate pool, and the borrowers take assets out of those pools. So there's no peer-to-peer element. It's lenders in the pool, borrowers taking out of the pool. Here you can simplify things an awful lot because you no longer need to exactly agree on loan terms and so on. Interest rates can essentially be set, as shown in the graph there, as essentially a function of how much utilization of the pool there is. If no one's borrowing from the pool, interest rates are low. If borrowers are taking assets out of the pool at a heavy rate, then the interest rates go up. And so long as the pool isn't 100% utilized, lenders can generally withdraw their assets whenever they want. So yeah, a much more capital efficient system. So the first versions of these peer-to-pool models were what I term monolithic lending protocols. I've got some examples there. And essentially how they work, rather than having just two assets, you want to have more than one asset in the system, of course. And typically you would have a subset of assets that are deemed useful as collateral, and you'd have additional assets which would only be available for borrowing. So going back to our little diagrams there, you can see that on the left, we have our collaterals, which can also be liabilities. They can be things that can be borrowed, and you have rehypothecation. The arrows go both ways. If I take out a loan of wrapped staked ETH using USDC, my assets can be borrowed whilst I'm taking out that loan. So this is really a nice capital efficient system. But it's not great for liabilities on the right there because they can't be used as collateral. And some of the trade-offs involved here are that essentially the system is only as strong as its weakest collateral asset. If you start adding really exotic, volatile assets into the collateral set there, the entire system can collapse if one collateral asset sort of collapses. So we've since seen the emergence of, to solve some of these challenges, we saw the attempt to create a different model of lending where we had instead isolated pools. So one of the earliest examples of this was the Cashew protocol created by the SushiSwap team. With isolated pools, typically you have just pairs of assets. And so you have a single liability and a single collateral. And this is really nice because in this system you can create, essentially use anything as you like as collateral. You can use a very exotic meme coin as collateral. And essentially the only person at risk, the only risk created in the entire system by this are the people depositing into the liability pool, so the lenders in that one pool. If one pair fails, then the system as a whole doesn't entirely collapse. Following on from this, Compound V3 launched with a sort of enhanced version of this, where rather than pairs of assets, they allowed multiple assets to be used as collateral for a single liability, which is increases the capital efficiency of the system. In this example here, Curve can be borrowed by multiple different types of collateral, and of course that, with extra borrowers, becomes extra yield for lenders. A nice experiment, one experiment, and sort of, change to the monolithic model that we saw that tries to maintain some of the benefits of the capital efficiency of that system whilst allowing more exotic assets to be used as collateral, was this fragmented monolithic model deployed by the Rari Fuse team. Here, essentially, they just created multiple mini instances of the monolithic protocol we saw before, with each one having a different set of collaterals and different parameters and so on. And so this allowed a lot more experimentation with different pools and gave lenders and borrowers a lot more flexibility in what they could access. But of course, it also led to a lot of fragmentation of liquidity, and ultimately the protocol wasn't successful. Another instance, another innovation was this thing I called isolated pools with mutual collateral. Here, notice that we have isolated pairs of assets now, but there's rehypothecation. You can deposit ETH and borrow USDC, and deposit USDC and borrow ETH. And what's interesting is that you can actually take out loans of USDC using Uni token here, even though there's no pair between the USDC market and the Uni market. Essentially, what you would do is you would deposit Uni, borrow ETH, and then you would deposit ETH and borrow USDC. So you're chaining together two types of loans in order to connect these markets. Some of the downsides of this model, again, is that we have fragmentation and you have increased complexity with different interest rates available now and so on. Okay, so just overall, which method's better, right? We have these kind of monolithic pools which seem more capital efficient but are vulnerable in some instances, have trade-offs, including the riskier collaterals, and then these isolated pools. So can we call out which one's better? I had this article published recently in which I claim that there's no objective better approach here. There's just trade-offs. And actually, for some people, you might prefer a capital-efficient monolithic pool, and for other individuals, isolated pools might provide you the flexibility you need. So in this article, I characterized the sort of problem in terms of risk management. I'll just take you through some of the different models that I think emerge here. So with a monolithic protocol, typically you require some form of risk management that's carried out by a risk management organization, which can either be a DAO or some risk manager that's hired on behalf of the DAO. And essentially, with the monolithic protocol, there's a single risk reward that's acceptable for everybody, or that's kind of imposed on the system by the risk manager. And so if the protocol's not providing the risks and the rewards you want, then tough, you just don't use it. Essentially, if we look at on the top here, we have the sort of different levels of risk provided by the collateral factors or the loan-to-value ratio that's available on the protocol. And we have a before and after scenario in which the economic conditions, the broader economy has changed and risk has gone up. And so what the DAO or the risk manager has to do essentially is slide the parameters down on the risk spectrum. And what this does is it takes everybody's user deposits and moves them to a lower risk state because of the broader economy. So I call it paternalistic and global paternalism because it affects everybody at once, and it's paternalistic because the expectation of users is that they're passive in this system. They don't have to actively manage their risk. The risk is being managed on their behalf. I'd say the alternative to this mechanism instead is the free market approach, where the invisible hand, Adam Smith's invisible hand, guides how risk is determined in the system, and you have risk management emerging as a property of the actions of many individuals and their behaviors. So in this model, the user deposits, rather than going to a single monolithic pool, they end up, each individual will deposit into a single isolated pool with a risk parameter that matches their desired risk-reward sort of tolerance. This is nice because it gives users flexibility, but as you can see, different users will deposit into different pools, and we end up fragmenting liquidity. Now, as the economy changes, the risk changes in the environment, we have the before state and the after state, and the distribution of lending shifts afterwards, driven by the active management of liquidity, the movement of liquidity by individuals themselves. And then there's a final sort of in between, I would say, for these two risk management models, which I call local paternalism, where rather than individuals depositing into isolated pools directly themselves, they instead deposit into some form of aggregator or sort of broker smart contract. And it's the job of the aggregator or the broker smart contract to handle user deposits. Now, it might that aggregator might decide to put everybody's deposits into a single pool, but more likely is that they'll have allocations spread across different risk-reward tolerances, and they'll manage those actively on the behalf of users. Again, this is nice for the lender. We have a return to more passive experience. They're depositing into an aggregator now, and they don't have to actively manage things. But of course, there's now an extra level of trust and reliance on this paternalistic aggregator or broker. So where does Euler fit into all of this, and what kind of risk management can we see, and what kind of capital efficiency can we expect to see on the new Euler V2 platform that we announced recently? This is the Euler.finance webpage. I encourage you all to go and check it out. And with Euler, we've created a new modular lending platform that we think combines the capital efficiency of the monolithic models with the risk management benefits and the freedom and flexibility of the isolated pools. So let's dig in and see how it's built. We've got two major components inside Euler V2. Instead of pools, every deposit goes into a vault. These are ERC 4626 vaults, which have become a standard across DeFi in recent years. And we have a vault kit where users can create and deploy vaults themselves in a permissionless manner. And the vaults themselves are agnostic about pretty much everything. You can deploy governed vaults, ungoverned vaults. You can add upgradability. You can customize loan-to-value ratios. You can choose your own oracles. All of this kind of stuff that's normally decided for users in monolithic protocols and other types of protocols is all flexible for the vault creator. And with all these vaults, we need a way to connect them together, and this is where the Ethereum Vault connector comes into play. So the EVC is an immutable primitive that acts as a communication mediator between different vaults, and it allows it says for any given vault what its set of collaterals is. It enforces the rules around when loans need to be repaid and how loans are structured. Essentially, it works as it's an abstracted system that works for any type of loan configuration, and it really helps developers to build their own lending protocols, margin trading applications. Essentially, anything involving credit can be built using the EVC, and we're building Euler V2, the Vault kit, on top of this platform, but we expect lots of other developers of credit-based systems to deploy and interact with the EVC as well. The nice thing about these two components is that with these two powerful modules, we can recreate any pre-existing or future lending product inside of the Euler ecosystem. So this is the EVC webpage. If you want to build on the EVC, you can check it out at evc.wtf. And if we dig into the Vault kit a little bit, there's, as I said, at the lower level, if you're a developer, you really have freedom to create vaults in any way you like. But if you're more of an ordinary user looking to come in and deploy your own vault on the website using a kind of wizard, we have three types of vaults that users can use. So we have core vaults, which resemble those that form the basis of protocols like Aave. With the core vaults, we have a structure that resembles a monolithic protocol. And these core vaults are governed typically by risk managers employed by DAOs. These enable a really nice capital efficient base for users to go in and at a basic rate of yield where things are set semi-conservatively. On top, aside from the core vaults, users are free to deploy their own edge vaults. And these are the vaults where they encourage a free market to emerge, or a market to emerge with a local paternalistic model where we have aggregators interacting with many different edge vaults and reallocating user deposits. We also have additional things which I'm not going to cover in this talk. We have synthetics and custom vaults if anyone's interested to dig into the further details. So yeah, why should users build on the EVC? There's a few points here. It's this interoperability layer for vaults. It gives lots of flexibility. So today I've been mainly talking about ERC20 or fungible assets. With the EVC, it supports the use of vaults and the creation of credit markets for all sorts of irregular assets. I think some really important ones over the coming few months are going to be real-world assets. But of course, the NFTs, synthetics, IOUs, all sorts of interesting things that people can work on. The hackathon that we're sponsoring this week is actually encouraging users to build NFT-based collateral vaults. yeah, the EVC has lots of other cool features that are slightly outside the scope of this talk. So yeah, what can you do with the EVC and the Euler Vault kit? I've drawn this absolutely horrendous diagram to really show the flexibility of the system. You can see over on the left-hand side, we've got a constellation of core vaults, which looks rather like the monolithic protocols that I displayed earlier. Over on the very far right-hand side, we have a couple of escrow vaults. These are collateral-only vaults, where you just deposit assets. You don't earn any yield, but you can use any token as collateral with these vaults. In the middle, we've got a mixture of a sort of garbled mess of edge-type vaults with all sorts of interesting configurations of assets as collateral. And down in the bottom right here, we've got somebody who's deployed their own sort of parallel core system as well. So yeah, I realized that basically that diagram looks a bit like this guy, and maybe it looks like madness, but why is it okay? Ultimately, it's okay because it's a modular lending protocol, and the modular nature, the abstract nature of things helps provide that safety and security that you need when building lending protocols. Modules are very simple things that do one thing and do it very well, and they're testable and providing, yeah, they're very easy to test and enforce simple rules on. To just give you an example of why it's okay to have this garbled mess of vaults that we saw here, let's just look at this very simple example. Here we've got link in the center that's going to be the asset that's being borrowed. And if you notice that for the lenders, they should really care what collateral can be used to borrow their link, which is why it's probably okay if you might accept wrap staked ETH as a collateral, but it's really not okay for dog or cat coins to be used as collateral to borrow users' link. So it shouldn't be possible in a permissionless manner for an existing vault to suddenly take on new collaterals. Basically, any lender that's depositing in a vault should care deeply about what's already being registered as for use as collateral for that vault, and if they're happy with that set, then it's safe to deposit. But notice that on the right-hand side here, it matters not one bit whether that vault is being accepted as collateral for other vaults. So if there's another wrap staked ETH vault that's accepting this link vault as collateral, that's fine. It doesn't affect the link depositors at all. In fact, it only ever gives them more flexibility. It means that the link that they're deposited and earning interest on can now be used to borrow wrap staked ETH from another vault if they wish. So it's perfectly fine as well for somebody to, in a permissionless manner, to create a dog or a cat token vault and specify that that link vault can be used as collateral. And that's really why it's okay to do this and allow people to build up vaults and chain vaults together. So I just want to give you a really quick example of a use case which could be quite interesting in the coming months. This is what I call super leverage by chaining together liquid restaking token vaults, liquid staking token vaults, and ETH vaults. One of the most popular trades over the past few years has been depositing staked ETH or other LSTs as collateral to borrow ETH. And I think what we'll see in the next few months as restaking becomes more and more popular is that we'll now see restaking tokens used as collateral, both to borrow liquid staking tokens, which are now in abundance and currently not being used to lend out, but also to use as collateral to borrow ETH. And as you can see from this diagram, when you have this kind of structure, the main winners here are the ETH depositors. Essentially, the yield flows from leveraged trades among the LRTs and the LSTs, and ultimately always flows from the highest yielding assets all the way down to the base ETH vault. And so I think there'll be lots of interesting trades that happen as a result of this, and this kind of vault chaining that's only really possible using the Euler Vault kit and the EVC. Yeah, so in conclusion, we've seen peer-to-pool beats peer-to-peer, but there are different classes of peer-to-pool models. There's monolithic protocols, which are capital efficient, but often rely on a level of paternalism that some people are uncomfortable with. Isolated pools are flexible, but fragment liquidity. There are lots of trade-offs, but ultimately you can have flexibility and freedom through modularity. And that's why Euler V2 is a game changer for lending this year. It allows any pre-existing or future lending protocol to be built using the EVC and the EVK, and allows DeFi protocols to accommodate all sorts of new and interesting assets, including real-world assets. And I think will finally enable DeFi lending to scale to many, many billions, even $1 trillion market. Thank you very much.
Real quick. He's just going to test the switch, and there you go. You want to put it in slideshow. Again, you want to make sure you're not mirroring.
What's wrong with mirroring?
Oh, do you want to have presenter mode and viewer mode? Or do you want it to be the same?
I'm fine with it being the same.
Oh, cool. Great then.
Cool. I should go downstairs.
Yeah.
Just to now so we make up some lost time.
Good to see you. Hello. I'm Britt. Nice to meet you, Jacob.
Nice to meet you.
All right, guys. It is late afternoon and you've learned so much. So I'm very excited to announce our next speaker. Let's give Jay a huge round of applause. Yeah.
All right, GM, everyone. Let's go ahead and get started. So my name is Jay. I'm a co-founder over at Say Labs, and we are building the first parallelized EVM. And today I wanted to take some time to talk about both what we're building and also go over some of the hot takes that our team has that might be a little bit controversial, especially at Denver. So let's go ahead and get started. So over the past couple of years, there's one thesis that we have started to develop, which is that the EVM is here to stay. 87% of crypto developers currently work on the EVM. So essentially everyone that's crypto native is an EVM developer. And if you basically ask them about moving to a new execution environment, let's say Cosm Wasm or any of these other execution environments, there's typically a lot of hesitation. And this comes from two major components. The first is it's a pretty big security risk. If you're comfortable with Solidity and you know the internals for how the EVM work, it's pretty risky to go to a new execution environment. Let's say write a smart contract in Rust. One small bug can result in your entire project getting drained. So it's super intimidating to go to a new execution environment. On top of that, there's also this idea of Ethereum alignment. and a lot of devs feel kind of icky. It kind of goes against their values if they move away from the EVM. And this is fundamentally because the EVM is not just a tech stack. At its core, the EVM is an ecosystem. It's not just the technology, but it's also all of the builders that are there, all the tooling that's been created, all the mind share that's around it, all the research that's there. And because of that, we fundamentally believe that the EVM is not going anywhere. Definitely not in the near future, most likely not in the medium or long-term future as well. The question then becomes, what is the current limitation of the EVM? Like, what is the biggest issue with the EVM? I'll make the argument that the biggest issue with the EVM right now is throughput, or more specifically, lack of throughput. So throughput is the general idea for like how many transactions or like how much work you're able to process per unit of time. And if you look at Ethereum L1, if you look at rollups that are built on top of Ethereum, they're not really able to get more than 50 transactions per second that they're able to process. So what does this mean from the user experience and the developer experience? Well, from the user experience, this means that you have to pay ridiculous gas fees. For example, I'm sure a lot of you have been doing stuff on Ethereum recently. If you're trying to do stuff on the L1, if it's 100 Gwei for gas fees, like you're going to be spending a shitload of money on gas. And I mean, look, no one wants to pay that kind of gas. That ends up resulting in most of the human population, honestly, just being excluded from participating on-chain. And that's definitely not the world that we anticipate having happen on-chain in the future. The other issue is it also becomes much more restrictive for developers. As a developer, if you're constrained to a 50 TPS environment, then it becomes much more difficult for you to build the kind of applications that you would see in Web2 or in traditional finance. And it forces you to make use of anti-patterns to be able to get stuff just working on the EVM. One example of this would be automated market makers. Like automated market makers, they do not exist in traditional finance. And the reason that they've started to become so popular, the biggest reason that they're popular on-chain, is because they fit the limitations of what the EVM really allows you to do. So there's a ton of limitations that come with this low throughput. So then the question is, how do you actually solve for this? And that's when parallelization comes in. So if you look at the landscape for EVM-based chains right now, they're essentially all single-threaded. So if you have 100 transactions that come in, you'll need to process every single one of them one by one. And this is super simple from an engineering standpoint to implement, but it's not performant. It's extremely inefficient, and it does not take advantage of modern hardware. Half of you are on your phones right now. Those of you that are on your phones, these machines have multiple cores. They're able to process multiple work streams simultaneously. And if you have single-threaded execution environments, you're not really making the best use of the hardware that you have at your disposal. So when you parallelize the EVM, it unlocks greater throughput, and that helps enable lower gas fees in a much bigger design space for developers. And that's kind of the inspiration for Say V2. There's a ton of different things that we've ended up doing as part of Say V2. We support the EVM. We've added an optimistic parallelization. We've created a new database layer, and we also have twin turbo consensus that I'll go over briefly as well. So if you look at how parallelization can be supported on-chain right now, there's basically two ways the teams have done it. Approach number one is by having developers define dependencies. This is kind of the approach that you see with Solana. When a transaction is submitted, all of the dependencies need to be passed along. The second approach is by having the chain itself figure out what the dependencies are. So this ends up leading to a much better developer experience, but then it adds complexity to the chain because the chain needs to figure out how to actually do this. But if you are able to have the chain figure out what the dependencies are, that is a better end state to get to because it makes the developer experience much, much better. And that's exactly what we've decided to do with Say. We make use of optimistic parallelization. And a super high level idea here is you try to run things all in parallel initially, then there will be conflicts for transactions that are touching the same state, and then you rerun those. The nice thing though is when you start rerunning transactions for a second time onward, all of the state that they're touching has largely already been pulled into memory. So it ends up being much more performant because you don't really need to worry about needing to read from disk. So with this approach, we've been able to start parallelizing the EVM. There is one downside though to parallelization, and that is state bloat. So state is the data that needs to persist to be able to process any new transactions that are coming in and to also be able to generate state roots. And at a super high level, what state consists of would be two kind of broader ideas. What would be account balances? So like I have 10 say, you have 20 say. It also has smart contract state. So let's say that there's like a Uniswap smart contract. What are the actual liquidity pools that are there? What are the tokens that have been deposited? All of that stuff needs to be persisted on full nodes, and it needs to be data that is stored on chain. The more throughput you have, aka the more transactions that are processed, the more state that actually gets created. And this is something you then need to account for. And when you have more state, the result of that is it leads to, first of all, more state storage that you need to manage. Like if there's 10 terabytes of state, then most consumer hardware is not going to be able to like just automatically support that. You need to start upgrading your hardware. Then that leads to more centralizing forces, because then you have people that are forced to run custom hardware to be able to run a full node, and that leads to issues. So you need to be mindful about how much state gets created. And then the second thing is state sync. So when you start to run a new node, let's say that you want to start running like a validator for the network, you need to import all the state to be able to start processing new transactions that are coming in. There's 10 terabytes of data that you need to import. That takes a lot of time. That could take on the order of hours, days, potentially even longer. And that has pretty significant impacts on the network as well. So you definitely want to be mindful about how to account for state storage, how to account for state sync. So to help with that, we introduced the idea of SayDB. So SayDB essentially has two major components. The first is a memory-mapped IAVL tree, and the second is async writes to disk. The way that the memory-mapped IAVL tree works is it has 3 files that are there on disk, and you take the entire tree, you split it up, and then you put it into these 3 files. This is different than the approach that SayV1 had, where the entire tree itself was just stored on disk. And when you store the entire tree, there's a lot of extraneous metadata that needs to get stored. One example of this would be if you have an intermediate node that doesn't actually have a key value pair, guess what? There's data that needs to be allocated for storing these key value pairs. If you have a child node, which is at the bottom of the tree, that doesn't have a left child or right hash, guess what? You still need to store something for the left hash and right hash. And that ends up leading to a ton of unnecessary metadata that you're just tracking. When you have these 3 files that are stored on disk as part of this memory map file system, you're able to avoid all of that extraneous metadata, which helps you get a 60% reduction in the state size, which is massive. Like that is a huge improvement on the amount of data that you actually need to persist. And when you have less data, that also improves state sync times, because suddenly if you have like only 40% of the amount of data that needs to be imported, then it makes it easier to import that data. Additionally, if you have 3 separate files that you're writing to, then you're able to parallelize writes to these 3 separate files. So that allows you to get roughly a 12x improvement in state sync times as well. So that's massive for helping prevent state bloat. The other benefit of SayDB comes from async writes to disk. So what happens with SayDB is you have all of this data that's stored in this memory mapped IAVL tree, which is these 3 files on disk. Then you pull as much data as you can into memory. Ideally, the entire IAVL tree will be able to live in memory. If not, there's subsets of data that you can pull into memory. And once you pull this data into memory, then you're able to generate the state root in memory itself. So typically, in order to finish block execution, you need to import this state root, or you need to have some kind of state root that'll be used as part of like the block header. And in the case of Say, like if you're able to have state root generation happen in memory, that makes it much, much easier for you to just kind of terminate block processing at that time. And then you can asynchronously write to a write-ahead log, and then also asynchronously actually write the data to disk. So this approach helps lead to a 287x increase or improvement in commit times, because you no longer need to actually wait for commit to happen to disk. You can just have it be in memory, and then afterwards, once it's on the write-ahead log, then you have disaster recovery. So it makes it much more efficient from that side, and that helps really improve the overall performance of the entire chain. The other thing that we're continuing to use, which is there from SayV1 already, is twin turbo consensus. So twin turbo consensus is Say's novel consensus mechanism, and this allows us to get 390 millisecond time to finality, which makes it, I mean, currently it is the fastest chain that is out there on mainnet right now, and this will continue to be the case for SayV2. And this has single slot finality with an internationally distributed validator set. And the 2 big unlocks that we had over here to get to this is optimistic block processing and intelligent block propagation. So the way that optimistic block processing works is kind of highlighted in this diagram over here, where normally what you would have is there's a block proposer who proposes a block. Other people in the network, they receive the block. And then from there, they have 2 rounds of voting, a pre-vote step, a pre-commit step, and then afterwards, they actually start to process the block. That is very inefficient though, because as a validator, like you receive the block, and then afterwards you don't do anything with the block for these 2 voting steps, which is completely unnecessary. So the idea behind optimistic block processing is that as soon as you receive the block, you can start concurrently voting on the block while also starting to process the block. And if you process the block, then you can update a candidate state instead of updating whatever the canonical state should be. If the block ends up getting approved by the network, then you can commit whatever that candidate state is. If the block is rejected by the network, then afterwards you can just discard the candidate state and there's not really any harm that's done. So with this approach, you're able to get like significantly improved time to finality. The other idea that we introduced was intelligent block propagation. The way that things normally work before is that there'd be some block producer who needs to send both a block proposal message along with the entire block of like, let's say 1,000 different transactions across the network. For a validator to start voting, they need to receive all 1,000 transactions, even if all 1,000 of them are already in their local mempool, because there's already a P2P layer where these transactions are gossiped. So the core unlock with intelligent block propagation is, what if you let validators try to construct a block locally before they start to wait to receive the block across the network? And what ends up happening is the block producer will just give a block proposal message, which will be an ordered list of transaction hashes. Then validators will receive this ordered list of transaction hashes. Then they can start looking at their own mempool, try to construct the block locally. If they have everything, which actually does end up being the case a lot of the time, then they're just able to process a block immediately. Otherwise, if they don't have it, then they're able to wait to receive all the contents across the network. So from both of these approaches, we've been able to observe 390 millisecond finality, which is, I mean, that is the fastest that you can have, that I guess any network has in terms of finality at the moment. Cool. So that's kind of where we're at right now, I would say. I also wanted to go over some of the more controversial ideas that we have, as kind of just based off debates that we've been having, or like ideas that folks have been kind of sharing about, say. So the first idea that we wanted to go over is we don't think it's a good idea to blindly focus on the number of validators. And I think especially at ETH Denver, this might be something that goes against what a lot of people believe in. But if you think about validators, like how do you actually incentivize people to run validators? Well, there needs to be some kind of mechanism in place that whatever the validator costs are, so this would be the cost of the hardware, operational costs, opportunity cost, all of that is made up through some mechanism. This could be from foundation grants, as you see in some ecosystems. It could be from whatever the transaction fees are, plus potential MEV redistribution, plus whatever inflation for the network is. But it's expensive to run validators. And if you have 100,000 validators, then you need to, the network basically is paying the costs for these 100,000 validators to remain operational. Otherwise, people will stop running them. So it ends up being very expensive. And most of the time, it's just like, you're just redoing the same work. Like if you have 100,000 validators, there's 1,000 transactions in a block, all 100,000 of these validators are literally rerunning those same transactions. And that is, I mean, it works, but it's not necessarily the most efficient thing to be doing. So if what you care about is decentralization, trustlessness, and verifiability, I'd make the argument that it's better to have a smaller, sufficiently decentralized validator set where people are then able to consume zero-knowledge proofs of whatever state transitions happen to be able to verify whatever state of the chain they want using some kind of flight client. So what this could look like, one approach would be there's like block producers or other participants in the network, they're asynchronously creating zero-knowledge proofs. And then light clients, like you might just be running a light client locally. This could be something that is just part of MetaMask. You would receive a ZK proof, and then from there you're able to just verify the state of the network without needing to run a validator, without needing to run a full node. So it allows you to have a smaller validator set size, which makes the network more sustainable. It allows these validators to be potentially more performant machines. And it also allows people to have verifiability and trustlessness of the network. So I think that's the model that a lot of chains are going to move towards in the future. It's also interesting because a lot of the more recent launches that have happened for L1s, like within the past 2 years, almost all of them have had smaller validator sets. And I think a lot of them are going to move in this direction as well. The second idea that I want to go over is that Validiums aren't full L2s. I think that there's a lot of folks that kind of view Validiums as like the best of everything, where you're able to get external DA while also kind of being Ethereum aligned in a way. But if you're using a Validium, then you're getting the minimum of the security between whatever the settlement layer is and the DA layer. So if your settlement layer is Ethereum, if your DA layer is Celestia, then you're essentially getting the economic, or you're getting security of the DA layer and not getting full Ethereum security. So you're not really a full Ethereum L2 at that point. You're closer to being like a sovereign rollup or closer to being an L1 than you are a true rollup. And I mean, we kind of created this diagram to go over that, but rollups are the only things that are getting settlement and DA from Ethereum. If you're not really getting DA from Ethereum, then you're not going to be fully Ethereum secured. And it's not really a true L2 in that case. One of the other things that we've started seeing is that there's a lot of focus on trying to improve disk reads, maybe from things such as like asynchronous I/O. And I would make the argument that instead of, I mean, you can definitely try to improve disk reads, but I think there's going to be more gains that happen from trying to encourage in-memory access as much as possible versus trying to focus on disk reads. Because at the end of the day, it's going to be impossible to get around disk reads entirely. And there is going to be an overhead that comes to reading from disk. And it's better to set up your mechanisms in a way to encourage in-memory access as much as possible. So LRU caches do this implicitly. Like if you have data that some transaction is touching, and then this data results, like if this data gets cached, then future transactions that touch that same state, they can make use of that data. So that is like one example of a very easy way to encourage in-memory reads. Another example that I think is going to start becoming more common with multi-dimensional fee markets in the future is different gas pricing based off of whether you're doing in-memory reads or if you're doing disk reads. So if you're doing in-memory reads, then you will ideally have some lower gas fee that you need to pay, and you'll get penalized if you do disk reads. And I think there's very deterministic ways of doing this as well. For example, you could have like priority state where people have some kind of auction to bid on priority state. And then from there, there's this priority state that is going to most likely get cash. And then from there, you're able to just ensure that you're getting as much in-memory access as possible. So I definitely think this is going to be something that you'll see start happening in the next year or two from different chains that are considering multi-dimensional fee markets. The last idea that I'm going to bring up is that async writes right now are underexplored. We observed a 287x speed up with CDB for commit times. And the reason that happened is because state root generation happens in memory. And then you're able to move on and kind of have the rest of the writes happen asynchronously. And I think this is an idea that overall has been underexplored. And it can definitely result in much, much better performance. And there's ways to ensure, like if you use a write-ahead log and you have like things getting written to disk afterwards, there's ways to ensure that there's like disaster recovery in place as well. So it's very easy for the network to be reliable overall. So yeah, I mean, I think there's a ton of cool stuff that is going to be explored from Say's side. And yeah, that's it from my side. Thanks, y'all.
You guys have made it almost to the end of day one. Everyone self give your own round of applause. Yeah. All right, we have one more awesome talk before you get to go to your happy hours, your team dinners, and everything like that. And it's a good one. We've got Thomas talking about how to unfuck Adtech, and that was fun to say out loud. Big claps.
Hello. Okay, awesome. So happy Thursday, everybody. Hopefully we can wrap this up with a fun one. But today we're going to be having an interesting conversation about how Web3 can unfuck Adtech. So just to kind of kick things off here, I'd love to get a show of hands. Who here hates ads? Awesome. Okay, great. Well, for everyone who raised their hand, fair enough. You guys have good reason. Ads kind of suck. From opaque targeting practices to some of the more intrusive ad experiences, the current state of affairs leaves a lot to be desired. Advertising infrastructure is not in the best place. For me personally, it's the spam in my email inbox or some of these pop-ups that I just can't seem to run away from on an ad or on a web page. So the question has to be asked, how do we fix this? And we think Web3 can help, but I think it's first important to have a little bit of background. So just a little bit about me. My name's Thomas. I'm one of the co-founders at Relayer, a Web3 native company building advertising infrastructure for the new internet. A better way to connect people to brands they love directly in the apps they use. But long before I was ever in ad tech, I was a crypto native that bought the top in 2018 and never left. So like you, I very much loved my crypto bubble and also very much hated ads. At least I did until I took my first venture-backed startup role at Card Financial. So Card offered rewards as a service in the form of these wallet-linked offers, the debit card and credit card cashback experiences that you might get in some of your favorite cards on the market today. While I was there, I worked with some really amazing brands powering a lot of awesome reward experiences, from Varo and Green Dot through to players like Robinhood and Coinbase that you might know a little bit better in crypto. But at the end of the day, we were essentially focused on building amazing, rewarding experiences. In fact, it was an extremely important part, almost table stakes of every card product on the market today, something that consumers expected, and led to this sort of a unique conversation that we're having today. You see, card rewards are table stakes. If I went out and I told a business, do you want, or told a user as a card, do you want to earn rewards from brands? Most definitely, you would probably say yes, and the market sort of shows it. Businesses like Amex and Chase Bank are the most successful card programs on the market at the moment. They focus entirely on building a rewarding experience that's native and personalized. But if they had gone out and asked, do you want to see ads, I expect that most people would probably answer the way that you all answered today, saying no. So why is that? Because whenever you pull back the curtain of the catchy buzzwords and phrases, they really are just advertisements. They're funded by brands that want to meet users in a unique way, get them to convert on behaviors, and even use rich personalized insights to help make the experience a little bit better. What it comes down to is that our brains like to think in a really funny way. You see, whenever we give a name to something, it really hurts our ability to think about it. You see, the stated preference that you all gave me here today is that you hate ads, but the revealed preference that we see on the market with some of the more successful financial applications is that whenever they're rewarding, you actually really like them. In fact, they're a primary decision maker for the way you go out and choose the debit card or credit card program that you might be interacting with. You see, we have this interesting dichotomy where some of the most well-used Chrome extensions today are ad blockers, but we also see that loyalty and reward programs are the biggest influential points for the average consumer on where they take their business. And it's not too surprising whenever you see a word as heated and controversial as the word ads. Our brains really would rather just think or believe than just think. We'd rather believe that we like rewards than think we'd ever like an ad. But whether you still feel like you might like ads or not, it doesn't really matter. Ads are the dominant marketing form and dominant monetization form of the internet. You see, these banking applications aren't integrating ads at the end of the day to make a more interesting consumer experience for you. They're integrating it as a way to monetize and drive more meaningful and sustainable revenue into their business. It's ultimately the end game for every modern consumer application. Everything is becoming an ad network, whether it's your social media app, your banking app, or your grocery store app. The implementation of these ad networks can lead to huge revenue. We're talking more growth, more engagement, and ultimately still a better experience for everyone. The classic example that we like to use is Instacart. They launched their debut ad network in 2022, and overnight, in 1 year, generated $740 million in ad revenue, a 30% increase in their total ARR in 1 year alone. So it's no surprise that applications might be interested in implementing this type of decision. And although it is happening in Web 2 and we're seeing it everywhere, Web 2 isn't alone. Unfortunately, Web 3 isn't a special snowflake. Ads run the internet and they're coming to Web 3 as well. With the consumer landscape finally beginning to take shape, it's leading to some really big questions. How do brands meet customers? How do platforms monetize? And ultimately, how do people discover things that are getting built and implemented? We've seen a lot of interesting implementations, from copycat Web 2 banner ads to the attention tokens, to quest sites, to even life-changing airdrops. People in Web 3 are in the arena and they're trying things. The question isn't really will ads persist, the question is honestly how. But the stated and revealed preference have given us some excellent insights on how to build these better building blocks for ads. You see, what we've determined is that ads need to be built as net positive consumer experiences, transitioning them from bugs and into features. We know that human attention needs to be rewarded, not exploited, that they need to be built for people, not for impressions, and that ultimately personalized experiences will lead to better experiences. And that's really good news for Web 3. Web 3 offers some really great ways to enhance all of these initiatives. Ownership distribution that's so native to the Web 3 environment will develop core alignment mechanisms between advertisers, publishers, and users. And this shared ownership and control will create a lot of trust and engagement, ultimately resulting in new layers of opt-in data frameworks. And blockchain transparency will enable advertisers and publishers to engage users in hyper-customized and interactive ways, ultimately making it a much better experience for you. But on top of all that, it's a lot bigger. It's a fresh start to build a system for everybody. You see, when Hotwire.com slapped the very first ad banner on their website in 1994, they weren't implementing it as a feature, they were implementing it as a bug, a way to compensate a gaping hole in their ability to pay money to their writers for doing content work. Web3 is a fresh start, a chance to go down a new path, a path to coordinate for a more human-centric experience, a valuable experience, not a embarrassing experience for a bad Web 2 ad that you don't want to see. And that ultimately comes down to the best way that Web 3 can fix ads. Web 3 makes a better coordination model. A quote that we really like is that when societies want to build schools and hospitals and infrastructure, but instead they build guns and bombs and planes, it's because they can't effectively coordinate together and disarm. This quote from Amin Soleimani at Moloch DAO is highly aligned, and although it may be a little bit violent, it's applicable. You see, advertising has still been a exploitative and unfortunate model that has caught a crossfire for people in the middle. A Web3 forward approach will allow for us to shift from these more top-down coordination structures and closer to a more frictionless market and decentralized network, one that will allow us to springboard towards a better path for everybody, not the best path for the Web 2 data oligarchs of Google and Facebook. So we've talked about what ads need to be and the direction we want to go and how Web 3 can help, but what does that actually look like? What do better Web 3 ads mean? Well, one model that we really love is a term that's recently coined by Olaf Carlson-Wee from Polychain Capital. Olaf talks about this idea about the incentives vortex, a new layer of consumer infrastructure that's embedding pre-existing application feedback loops with a new financial incentive backbone. If you add the word brand funded in there, it sounds an awful lot like ads. But if you're like us or most people on the market, you don't want to use the word ads, so we'll go with incentives. This solution specifically is the thing that our team at Relayer has been building towards for over a year. And we'd like to share a little bit about how we're thinking about it. And the approach we're taking is that of the Wayne Gretzky game. For those of you that don't know, Wayne is a famous hockey player who's most notably known for his quote, "You miss 100% of the shots you don't take." And we definitely think Web3 needs to take a shot at building a better ad system. But More importantly, we like the quote that a good hockey player goes where the puck is, and a great one goes where the puck will be. And we've been lucky enough to identify this incentives vortex, this better solution to ads that could happen and could create a better internet for everybody. And we've looked out 30 years, and we said, how do we get there? Thankfully, Web3 has been identified as this favorable exponential that will help us accelerate and get there much quicker. So what's the earliest form of this thing? That is the app-linked offers experience that Relayer has been so focused on building natively for Web3 to begin embedding as consumer infrastructure continues to grow. An inflection point that will allow for us to accelerate and go to the next level, not only building better ads in Web3, but proliferating them externally into the broader market. That inflection point is extremely exciting, where we're no longer focused in the ad tech sector on the irrelevant ups and downs of optimizing for clicks or impressions or customer acquisition costs, ultimately ads that are bugs, and moving towards an era where ads become optimized features that improve your product, not only allowing for you to be more viable and sustainable, but also allowing for consumers to consume in a more personal and rewarding way. That relevant thing is something that we're excited to continue building at Relayer, and we'd love to connect further to share our vision and how we're continuing to develop that. We'd also like to shamelessly plug at this time that we are hiring, so if you'd like to come build with us, please come reach out. Thank you.